Hi, I'm Narender Kumar. I'm a senior data architect with 12 years of experience in IT. I'm a Microsoft certified architect and Databricks MVP as well. I have been using Python in multiple projects by now. And whenever I interview someone to get into my team, I look for very strong programming fundamentals. And that is where I thought of creating this video where instead of looking for people with strong programming, I can help some people to build their strong programming fundamentals. And in this video, these are all the topics that we are going to cover, starting from very basic to the very advanced AI chatbots. And this course, it is going to be very beginner friendly. So even if you don't know P of Python, you will be able to understand everything and do all the hands-on yourself. In this video, we are going to cover all the theoretical parts as well as the hands-on. And to make it more practical, I have created these notebooks where we will write each and every piece of the code as we are going through the topics. And all these notebooks, I have uploaded them on GitHub so that you can download them for free and then do all the hands-on yourself. And after watching this video, you will be able to write any code in Python confidently and answer any interview questions as well. You can also subscribe to my channel to stay up to date about data engineering and AI related stuff. So without any delay, let's get started. Let's start by understanding what exactly is Python and why it is so famous. So Python, it is a high level general purpose programming language. High level, it means here we write the code at a very high level and explain what we want to do as a function without worrying too much of its internal memory and internal functionality. And it is general purpose programming, means it can be used for any use case that is there. Wherever we need programming, most of the things we can do in Python. So it can be used almost everywhere, like back end, front end, AI, whatever we want to do, it is possible in some way using Python. And it is known for its readable and clean syntax. So when we write a program, it is very readable, it looks very clean, so that it is very easy to understand any code or write any new code. So simply putting, Python is a very powerful programming language which can be used for so many things, and it is very easy to read and write. And now let's understand why Python is so famous. So there are various reasons. First one, it is simple and easy, like we were talking already. Writing the code and understanding it is very easy. Any new person can understand it very quickly and then work on it almost immediately. Second one is productivity boost. So as it is very easy, we can like write it very easily. And the way it is designed is that we need to write very minimal things to achieve the functionalities. And if we compare it with other languages like Java, where I used to work, we need to write very less code here. And that gives it a productivity boost so that in very less time we can do so many things. And the third one is like cross platform. So the same program, it can run on Windows, Mac, Linux, and anywhere we want to run it. And the next and very important reason is rich standard library. So Python, it has so many ready to use modules, which makes it very easy to use. And people across the world, they have built very standard libraries for almost anything. We will understand these, we will use some of those. But overall, whatever we want to do, people have built some framework or library around it. So we can directly bring it in and then use it for free. And then the next reason is that it is powering the future. So as AI and machine learnings are advancing, so the underlying engine or the underlying language that data scientists, engineers, and AI people are using is Python. Because building things here, it is very easy and powerful, and with it gives productivity gain. So everybody is using it, and now as we are focusing more and more on AI, Python is also evolving more and more with time. And now, as we understand why it is so famous, let's quickly also understand how it all started. So, if we look into the history of Python, it all started in 1980s. So, we had this programmer whose name is Guido van Rossum. Forgive me if I'm not able to spell it properly. But this is the person like who first built Python from scratch, and he was working like on this Python as a internal project, and he's a Dutch programmer. In 1991, they released the very first version of Python, and this one they call it as a spiritual successor of older ABC language. So before Python, this guy was working on another programming language, like building another programming language, ABC language. The target was to make it very simple and friendly to use for newcomers. uh, and that is where that philosophy he brought it into Python, and then Python was released as a spiritual successor of ABC language. So in 1991, when I was born, that is the time they released Python very first version. And then the major update happened in 2000 year, when they released a 2.0 version of Python with lot of enhancements. And the third version of Python, it was released in 2008. That time, like it was a complete redesign, and they made major improvements here so that it was not even backward compatible. It means like whatever program was written on 2.0, it may or may not run on 3.0, but there were some very important design changes. And now like there are various versions of 3 onwards which are going on. So everything that we use today is compatible with a third version of Python, and everybody use this v3. And if we talk about it today, so everybody is using this third version of Python. This language is evolving a lot, and now it ranks among the most used programming language on our planet. So that's all about the history lesson. I hope now you understand what exactly is Python, why it is famous, and how it evolved over the period of time. So now let's go ahead and install our setup, and then we will start writing our programs. To set up Python, simply we need to open any browser and search for Python download. And we can open the very first link. Here we can download this install manager or install it as a standalone. I am installing this one. Both way it can be installed. And I'm currently using Windows. If you are using Linux, Mac or any other system, then you can download accordingly. So now this setup file has been downloaded. I will simply open it. And here is the setup screen. So I will click this, and I will also select this one, like add this one to path. What it will do is like it will add the Python path to the system path variable, so that we can access Python from anywhere. This one is optional. You can tick it or untick it. We don't really need admin privileges. So I will simply go ahead and install now. And now we got a pop-up saying that it is installed successful. So just to confirm that it is installed properly, we will go to the search bar and type cmd. Basically, we need to open a command prompt depending on our operating system. And here we need to simply type Python. So here we can see that Python 3.14.7 version has been installed. This is the recommended version that was directly downloaded. If you already have some older version, that is also fine. So whatever code we will write, that will work everywhere. So this is the Python command, like the Python terminal that is there. Here we can write any code and try executing it. For example, if we simply want to print some message, let's say hello. So print is the command that we use. And then in this round brackets, we mention the message that we want to print, and the message has to be in between double quotes. That is how like it can print it. So simply if I press enter now, it has printed hello for us. So I know it is very basic thing. We will go like more detailed programs later on. This is just to confirm that the Python is working fine. So this it confirms that Python is installed, it is working fine. And although here also we can write any program, but this is not a recommended way, because here we are not saving anything into file, and we won't be able to use this code later on once we close this window. So this is one way to use Python. Now let's look at the second way to use it. So in this way, what we need to do is, this is a blank folder I have created for testing purpose. Here I will create a new file. So new and simple text file I will create, and I will name it as, let's say, test.py. Py means it is a program that we are writing for Python. So this warning I will ignore. So this file is created now. If I right click this file and edit in Notepad, it will open this file for editing. So this is the screen. Now here if I type the same thing that we had typed there, and I press Ctrl S to save it, it is saved now. So now this is a Python programming file that is ready to be run. So to actually run it, what we need to do is we need to run it from command line. So if I click here in this top bar and just type cmd, so it will open the command line and the current folder it has already been selected. So if I have to run that file, I can simply type Python and then the name of the file. So name is test.py. So if I press enter, we can see it has printed hello here. So now whatever code that was written into this file has been executed and output has been shown here. So this is also another way to run Python. But as you can see, this is also not user friendly for anybody to learn and all. And it is not visually also like, it doesn't feel that good. And that is where we have a third way of using Python. That is the one we will use in this entire exercise. So to write program for any programming languages, we as a developer, we use a IDE. We call it as integrated development environment. And there are different IDEs like Eclipse, VS Code, and there are others as well. We will be using VS Code, which is from Microsoft. We can use it for free. It is very famous and I use it every day. So let's go ahead and install VS Code. And for that, simply we need to go and search like VS Code download. Then any link that we got which says Visual Studio Code. So this is the one we are going to download. Here also we have different version depending on the operating system. I'm using Windows, so this is the one I will download and install. So this is something I have already installed. So I will open mine. So after installation, this is the first window that we will see in VS Code. And in here to start with, we have different options like we can start with a new file or we can clone a repository and all. So in our case, I have already created some good notebooks that we will use. We need to copy this URL, then go to VS Code and click on this clone git repository. Then at the top, this will appear. Here I am pasting that URL and we need to click on this clone from URL. Then it will open this kind of folder where we want to store these files in our local system. So here we can store them anywhere. So I will simply select any folder. So here I will create a new folder named, let's say, Python course. And then I will select this button, select as a repository destination. So now it will clone all the files those were available in the GitHub and then it will open. So we can click open now and I will maximize it. So here we can see that whatever was in GitHub, it has been cloned here. So here before start writing any code, we need to install Python extension here. This VS Code, it can be used for multiple programming languages and Python is one of them. So there are different extensions. So for Python also, like there is a Python extension. So if we search Python, we will get this extension. We simply need to click on install. So after a few seconds, it is installed. I will close this now. I will go back here in the Explorer where we have these files. So to now let's confirm if we are able to run something on Python here. So I will click this icon, new file, and simply type test.py to confirm if we are able to write and run something in Python. So here we will type the first command, same command like printing the hello to confirm that it is working. So I have typed this and then pressed Ctrl S to save this file. So after that we get this run button, run Python file. So if I click this button, it will open a terminal and it will run my file automatically. And as we can see, it has printed hello here. So this is the way like we can create any Python file, we can directly run it, we can check out the output and everything. So that is these are the advantages of IDE. It makes it very easy to write and execute the code in a friendly manner. We can create other files for anything and then use it. So I would say like this is how we can write the program. But to make this video and learning Python making more interactive, there is like another type of files that we can use to write and execute Python code, which is also very standard way. So if we go to practice notebooks, so in this folder, I have two sections, practice notebooks and solution notebooks. So practice is where we will, where the code is blank, we need to write the code and execute it. And if anytime you want to see what shall be the code that shall be written, then you can go to solution notebooks, open the same notebook, and there you will see that the code has been filled. So this is the notebook. Sorry. Yeah, this is the notebook which is practice notebook. And here you can see I have put some placeholders. And if you see, these notebooks are in the format IPYNB. So this is called as Jupyter notebooks. This standard format, it means Jupyter notebook. This format is very famous across different environments. We can use them in cloud services like Databricks or like anywhere we want to run. So basically, whatever are famous services, those support this format. And the advantage of this format is that it is not a simple text. As you can see, I can provide some instructions and then I can provide some placeholder where you can write and execute your code. So that is the advantage of this, so that we can understand and run one step at a time, and this will make it more interactive learning experience. So now I will minimize this solutions notebook folder, and this is where we will write our very first program. So here the task says like simply print the message hello world. So I will simply say print and then I will do this hello world. Okay, so if I have typed this code, then we get this run button. After running it, it will run this code and then show this output. This output is showed from previous execution I did, so it will be replaced. And as we will be running it for the very first time in our setup, so it will request to install some extension and some more things. So let's go ahead and click this run button. So first of all, it is saying like install or enable suggested extensions. So Python plus Jupyter. So it is a extension. Either we could search it manually or it is giving this pop-up automatically. So I will simply click it so that it will install that Jupyter extension automatically. And after it has installed the extensions, now we are getting this option like Python environments or existing Jupyter server. So we will click this Python environments, and now we get two options here. Like either we can select directly the Python that we have installed. This is where it was installed, or we can create a Python environment. So here we will create a Python environment, and I will explain about these environments later on. For now, we will go ahead and click create Python environment, and we will select this quick create environment. So now it is creating an environment for us. So simply in simple terms, like what environment it does is here it has created it as a local folder .venv, and it is like a local copy of Python. So when we work on multiple projects, instead of installing different things into the main Python, we install in kind of a local copy of the project. so that in different projects we need different libraries, different version of libraries. So maintaining a local copy, it really helps. That is where whenever we work in Python, we always create a virtual environment and then only we use it. So it will take a few minutes. I will pause the video for now. So after a few minutes, it is virtual environment, it is ready, and we can see that this print message has been executed. So now we can confirm that this notebook environment is working fine, and this is what we will use throughout this exercise. And let me increase its height so that it is more properly visible. So I will close this terminal from here because for now we do not need this. And this is the advantage of the notebook as well, that whatever we have executed, here itself we can see the output. And then we can go step by step further. And whatever instruction you see here, so although like you can see this hand icon, this doesn't seem to be editable. So if we double click it or if we click this edit icon, this also can be edited. So this is a special different language or format which is called as markdown format. You don't need to worry about anything because you don't need to modify any of this section, but it is only for knowledge purpose, that wherever we want, like we can create this cell, like this is one cell, this is a code cell, and we have different type of cell. So if we click here, we have this code and markdown. So if I click code, this is where we can write any code and then execute the code. So here if I say hi, we will be able to execute it. So if I run, it will execute it. And if I click on markdown, this is where we do not write a code, but we write this kind of instruction. For example, this is an instruction. So this is a simple text. If I click OK, so this is how it will appear as a text. And this text, it has different formats like hash. Hash means it is a double heading and special keyword. So we won't go into too much detail here, but this is like important to understand that if we double click it, we will be able to see it in case we want to copy something or check it out. And if you are using for the first time, probably you will see another type of cell as well, which will say like generate using AI. And that is where I have disabled the AI features in VS Code in my version, because if we want to build a strong foundation, AI can become an enemy. So that is where I recommend that you disable the AI feature. So let's understand how we can disable it. So why I want it to be disabled is, let's say if it is enabled by default, so whatever code you will write, it will type ahead. It will give you a suggestion that you type this, and if you press tab, the code will come automatically. But that is what not I want you to do. I want you to write each and every line of code in this exercise yourself, so that you will understand it better. When you will write it, you will make some mistakes, you will learn from those mistakes. So that is why if you are learning programming, you want to build the foundation, then disable AI and then do it yourself. So to disable the AI features, we need to go to this settings icon, and then we have this settings option here. And here, if we search for AI feature, so we will get this kind of a tick box. So by default, it will be like this. So we will be able to use AI features. And on the top bar here also, you can see AI agent icon is coming. If you tick it, then AI features will be disabled. And that is what I want you to do. So throughout this exercise, you shall keep this ticked so that you don't use AI and you use your own brain to do the things. So this is a very first program that we have written, just printing something. And here we are printing just a string. And by string, it's a programmatic term for text. Whatever text we are using, we call it as string in terms of Python or in terms of any programming language. So string, as you can already see, we need to put it within quotes. So either we can use double quotes or we can use single quote as well. Both are supported in Python. So if I use single quote like this, and then if you run it, you will get the same output. So although we can use single and double quotes, but preferred way it is used double quotes. That's the standard that is used. And also to run this particular cell, you can click this button or you can use the shortcut as well, which is control plus enter. So if I uh, press control and then if I press enter, it will run this cell. So after some time, you will be familiar with control plus enter and you will be using it everywhere. So this is how we could simply print a string. Now, if we want to print a number, then we do not need to put it in quotes. So simply if I go ahead and say print 7, it will simply print that 7. So numbers, those can be shown or printed directly without any quotes. But if you, let's say, use print a, which is a character, so it will not let us print. We need to put it in double quote. And the reason for that is like the name of like anything other than number, those are used as a variable names. And Python, it will not know like whether that is a variable or real string. That is why we need to put them in quotes. And that is where let's understand how to store something in variable. So variables, we will understand them in more and more detail. But for now, let's say if we use the variable with the name is. So these cell one by one, you can read out this task and then write the code. I have created it that way so that you can keep performing that task one by one and you can understand and learn one step at a time. So here we are saying that we need to store the number 25 in a variable called is and then print it. So to create a variable, simply we need to type the variable and then equal to 25. So here this is a variable is and this is the value that we have assigned it now. And then if we type here print and then instead of 25 if we print is, so how it will work is this is the name of the variable is which has the value 25, and when we print that variable, the value of the variable will be printed here. So here we will be able to see 25. We will understand more type of variables later on, but this is how simply we can store it. And if you can see, like we simply do not need to even specify that if it is an integer, string, or other types. Simply we can assign it and then use it. And here we stored a number inside a variable, and same way we can store string as well. So here in the name we need to store like the text as Sam and then print it. So this is the name of the variable equals to, and in double quotes we need to, let's say, type Sam, or we can use our name, nothing matters. And then we need to print it. So if we print the name, and then it will print the value of this same variable. So variable directly, those can store number, those can store any text as well. And here so far we have stored one thing at a time and then printed it. Similarly, in a single sentence, if we want to print a different type of variables, those also we can use. So here, let's say the task is like print this message. My name is this, and I am this years old. So this variable is already created with the name and the age, and this is the thing with this Jupyter notebook. So whatever variable or something has been created in previous cell, those will be available here. So here also, if I try to print name, it will be able to print it because it is already stored in the previous cell. So and that will work only if we have executed it. If I had not executed it and directly if I run this, it will say error. So now we need to print this message. So what we need to do is here we can see that my name is, this is kind of a text that we need to print. So we already know like how to print it, like my name is. So if I run it, it will just print my name is. And now if I want to include name here, so simply what I will do is like there is a simple function available with the name plus. So if I say plus and then I say name, so it will be able to print my name is, then value of this name. And here it is printing this value because this is not included in double quotes. So whatever is in double quotes, that is a text that as it is, it will be printed. And here, if we are giving the name of the variable without double quote, then the value of the variable will be printed. And here we see that there is no space after is. So here I can give the space and then print it. Now we want to say that and I am this many years old. So what we will do is again we will say plus. Now we need to type and I am, and then we need to put the value of the age variable. So we will say plus age, and then we will say like how many years old. So we will say this many years old, and here we need to put a plus as well. And now you may be hoping it will just run fine, but this one it will throw an error saying that we cannot concatenate, we can only concatenate string and not int. Int means integer. So this is a string. Name, it is a string because it is a text. Is because it is a number. So it has different type of variables. So directly in the print message, it cannot print a number directly. So we need to convert it to string. So this conversion and different type of variables we will understand in more detail later on. For now, just understand that putting this str is a short form for string. Now it will convert the number is to a string, and then it will be able to combine multiple strings, and then it will be able to print this number here. So this is how, like in the same message, we can include, let's say, hard coded text, variable text, and variable number as well. So this is, I would say, a very basic programming we are doing so far. And then whatever program we are writing, in every programming language, we need to write comments. Comments are the line of code that is not executed when the code runs, but those are just to explain what is that code for. So, for example, if I copy the same code and paste here, and here above this line, if I press hash and type like say that this is my first program to print name and age. So this is a comment we have given. Now when we will run this code, it will actually ignore this line. Python, the Python interpreter, it will not consider this line for execution. And that is where if I share this file with you, you will be able to understand by reading this comment that why I have written this line and other code. So that is why comments are very important. And in Python, whenever a line start with hash, that is considered as a comment and that is never executed. So if we want to write one line or multiple line, so those also we can write here. So let's say another comment. So multiple lines also uh, can be written as comments here. And one more thing we can use comments also is that if we are we have lot of lines of code. Let's say here we have another line which says hello. So now two lines are executing, and due to some reason I do not want this line to be executed. So if I put hash before this, it will be considered as a comment and it will not execute it. So this is also another use case when we shall use comments. And whenever we write a good program, we write lot of comments so that any new user, they can understand why this program has been written. And multi-line comment, that is something we already understood here. Like if we have multiple lines, everywhere we can start with hash and that will be used as comment. And then asking the user a question. So if we want to take some input from user, then there is a simple function available with the name input. So when we normally use it so if I take an example, let's say here we provided the name is hard coded here. Within the code only we provided our name. But let's say if we want to provide the name when the program is actually running, then we can use this input function. So how do we use it? Let's say the name of the variable, and then instead of providing the value, we call this input function, and then let's say we ask a question. Let's say, what is your name? So when this program will run, it will ask us to enter our name. Whatever name we will enter there, it will be stored in this variable, and then we can do anything that we want. So let's say here, if I want to print that name, it will be able to print it. So if I run this program, so at the top, this is where it is coming up automatically. It is asking what is your name, and then press enter to confirm. So here I will enter my name Narender and press enter. So once we press enter, my name is printed here. So that is how simply we can ask for any input from the user and then use it in a variable wherever we want. Here we have taken only one input. If we need multiple inputs, those also we can take them one by one. And with this, I would say our first notebook is complete. And in this notebook, what we understood is we were able to print different things like printing texts and numbers. We were able to use variables. We understood how to use comments. And we also understood how to use input to ask a question and then save it in a variable. And now, before we go to the next notebook, let me tell you some quick options in the Jupyter as well. So here we have these options. So we get this option clear all outputs. If due to some reason we want to just remove these outputs that were shown here. If we click on this run all, it will run each and every cell that is there. You can see just by printing there, it is able to run everything. I'm giving my name again, and that is what it is printing here. So we can use this run all button also if we want to run everything. And then there is this but this option here which says like which virtual environment or which environment it is currently connected. So by default, it will show like select kernel or something, and here we can change it as well by selecting another kernel. In our case, like this is the only environment that we are using, so this is already selected. And sometimes like a problem may happen here that I noticed that if you are running something, it will show it is running, but it is kind of stuck. It happens with me, it happens with every user. So in those cases, simply what we need to do is we need to simply close the VS Code from here, then open the VS Code again, and then run it again, and it works. So that hope doesn't happen frequently, but sometimes it happens. So I'm telling in case you face that problem. So now, after understanding these core things, now let's go ahead and understand some Python core basic things. So in this exercise, we will start by understanding different type of variables. So in previous exercise, we already saw the normal text and a number, and here we will go in more detail. So let's say number, as we were talking, we took the example previously of A's. It is just a whole number, that means without any decimal. So that directly we can store it and print it. If I print the number, it will print it. And if you are running the code for the very first time, at the top you can see it is asking to select the kernel, and on this right side you can see it is not selected. So if I select it, then it will select that, run my code, and then it will be shown here. And this is how like it is stuck, the example I was talking about. So sometimes when we switch it to a new notebook and run it for the very first time, so it is this top icon, it means it is currently pending or waiting, but it is stuck. Normally the execution is immediate. So to come out of it, simply I will close VS Code now. I will save my changes, and then I will open it again. So simply I will search for VS Code here again. And after opening it again and running it, this time it is able to complete quickly. So this is a number which is called a whole number, and we call it as integer as well. And if we have any decimal point like this, then that also easily we can store. So if we have, let's say, 12.5, then that will be stored and it will be printed. So although it seems like something very simple, And that is how Python works. But if we come from Java or any other programming background, I would call it as a luxury. There we had to specify, like before creating a variable, whether we are creating a integer, string, decimal, all those we had to specify. But in Python, that is the simplicity that we just specify the value. Depending on the value, the type of the variable is created automatically. We will also understand like what I mean by type and how we can see the type as well. But for now, like we have tried using a whole number and a decimal number. And the other data types which are available are text. Text one, we already saw that how to use it. For example, we used name already. So this is called as text, or we also call it as string. So this one directly we can use it and print it. So let's say if I print name like this, it will be able to print it. And then we have another data type which is called as boolean. So boolean is the full form. Sometimes it is called as bool as well. And that can store only two type of values, true or false. And this also comes very handy when we have to check some conditions, true, false, and all. Those we will understand later on. But this is also a variable. So this is, let's say, a name. And to store true, like this is how we can simply use it. So now we have created a boolean, and if we print this, it will be able to print the same. So it is able to print it. So it has only two type of values, true or false. So false is like this. And Python, it is case sensitive. Sensitive means like this has to be capital F only. If we put small f, it will not be able to recognize it. So that is where like the names, those are very standard, and we need to use the right lowercase or uppercase only. In this case, the T and F is capital. So this is what a Boolean data type is. And then we have like another data type which is called as nothing or none. That is used to store basically nothing. So if we have any like a blank variable, let's say something like this, our name is already there. Maybe let's say test. So by default, we can't create something blank. Okay, so to create a blank variable or to store some blank value which has nothing, we have this special type which is called as none. So if we assign this value, if we try to print it or let's say use it, it will say none only. So basically none means it is empty and it is having no value. So it may sound like something silly for now, but this is very useful when we go to other use cases. So one is that we can create a blank variable and then assign values later on. And two, like none as a condition, it can be used. Let's say if some variable or some in some response, some value is none, that means it is not coming, or if it is there. So those kind of conditions we will be able to use. So this is also like another data type or variable type. So although we are saying these are different variable types, but you may say I don't see any difference. So why we will say that it is a different data type? So whatever variable or basically anything that we create in Python, it has its own type. So to see like what type of variable it is, simply what we need to do is we need to use this function type and then type the name of the variable. So the name that we had created previously, so we can see it is a variable of the class str. Str means it is string. Similarly, if we check the type of this test which had stored none, it is a variable of this class none type. We will understand what is a class and all later on. But here what I mean to say is that although we are simply specifying these values, but internally it is creating a small object of any of this class. And similarly, if let's say if I check this number, type of this number here, so then here we can see it is coming as float. So if it is a decimal number, it will say float. And if it was let's say something without decimal. So let's say if I give my number equal to 5, and then if we check its type, then let's see. So then it is coming as int. Int means integer. So depending on the value, the underlying mechanism of storing these values is changing, but we don't have to worry about it. But this type function, it can come really handy. So just checking for variables, it will not be that much practical use. But apart from number, whatever variable, whatever thing we are creating in Python, we can check its type, and it will come very handy later on when we will be not be sure what type it is currently. And now comes like conversion of the types. So like uh, uh, we were using it in the previous exercise where we converted a integer into a string. So now like that is how simply we can convert from any type to any type, but it has to be a valid type as well. So here let's try something. Let's say we have this number, any number. Let's say if its value is 42, and it is saying like convert it to a whole number and then print it. So by default, let's say if it is string, and if I try to print it, there is a typo, let me correct it. If I print it, so in terms of printing, we will not be able to say that there is a difference. Sorry, we need to print the number, not print. So it is printing 42. But let's say if we are assigning it as a whole number, so now also it is able to print it as a standalone number. But the underlying thing that I was talking about, that is what is changing here. So apart from simply printing it, let's say if we also print its type here, let's say we want to see type of number. So now we can see it is int, and if I put it in double quotes, then we will see that it is a string. So if we want to convert this string to a number, then what we need to do is, let's say we will say number 2, that is equal to string of number 1. So now it will convert this number to a string and then store that value into this number 2. So now number 2 will be created of type string. Sorry for the confusion. We want to convert it to integer here, not string, because it is already string. So we want to convert it to integer. So now number 2, it will become an integer and not a string anymore. So here if we try to print this same thing again for number 2, let's see what type it is printing. So here we can see this initial 42, it was a string, and the later it was a integer. So this is how like we were able to convert it. And when I was saying it has to be of valid type, so let's say if I say instead of 42, if I say ABC, it is a text. This actually cannot be converted to a number because it is a text. So when we try to convert this way, the code will fail. It will say like the ABC, it is an invalid literal or invalid value. It cannot be converted to integer. So we have to be careful, and we have to be responsible whenever we are using this kind of conversion. And to handle these conversions properly, later on we will understand how we can handle errors, exceptions, everything. But here simply what we want to convey or understand is that using this kind of a data type mention, we can convert from one type to another type, and that value, it has to be of valid type. So this is all about variables and converting between them, their types and all. Now let's understand some operators. So operators means like if we want to do some operation between different variables, then we use different type of operators. So first one are arithmetic operators like plus, minus, multiply and divide. So as you may already guess, so simply we can add two numbers, subtract the numbers and everything. So the task here, it is to store two numbers and then print their sum, difference, product and division as a result. So let's say we have two numbers. So we have, let's say number 1 is, let's say 10, and let's say number 2, it is let's say 2. And if we want to print something, so we have this, let's say number 1, then plus is the mathematical operator or arithmetic operator. So if we say print number 1 plus number 2, it will be able to print their sum. Similarly, if I press minus, it will be able to print their difference. And for multiply, we use star, so it will be multiplied. And for divide, we use this forward slash. So this way we will be able to divide it. So these are the arithmetic operators that we can use. And then the next ones are comparison operators. If we want to compare two variables and then decide whether those are matching, not matching, or define different conditions, then we use comparison operators. So for example, if we want to confirm if two values are equal or not, so let's say if we have a variable a which is, let's say, a 10, and then we have a variable b which is also 10, and if we want to know if both of these are equal or not, so for that we have this operator which is called as a comparison operator. So equal is one of the comparison operator. So here, because both are having 10 values, so it is printing true. So they will always print true or false. Only two output they will provide. So if let's say this one was 11, then it will simply print false. So this is one of the comparison operator. We have others as well, like not equal to. So if I say not equal to, then whenever both values are not matching, then it will say true. So in this case, now it will say true. So it is opposite of equal to. Then we have these things also, let's say greater than, less than, equal to, all those things also come under comparison operator. So for example, if I say a greater than b, is a greater than b, 10 is not greater than b, so it will say false. If a was greater than b, some bigger value, then it will say true. So these are called as comparison operators. And then the next set of operators, those are called as logical operators. So we have three logical operators: and, or, and not. If we want to combine multiple conditions into combine different things into same condition, then we use this kind of operators. So what I mean by that is, so let's say if I take the same example here, okay, and let's say the I'm taking a condition here. So let's say condition 1 is equal to a greater than b. So this will, in this case, is a greater than b? Yes. So condition 1, if we try to print this condition 1, it will print true like this. So it will print true. So what it means is that this is one condition which is true. And now let's say if we create another condition, let's say condition 2, and this time let's say we say that a greater than 0. So let's say we also want to confirm that a is positive or not. So if we print condition 2, it will print true here as well. So this is another condition which is also true. And normally, like, we use underscore as a best practice. So this is the naming convention followed as a standard, so that these looks more readable. So now as we have these two conditions, so now let's say we want to create some let's say condition 3 which can be prepared from combination of 1 and 2. So what I want is, I want this a new condition. So when both conditions are true, I want it to be true. And if any one is not true, I want it to be false. So if we run this kind of scenario, then we have a operator for that which is called as AND. So what it means is that if I say condition 1 and condition 2, so now this condition 3, it will be true only when both of these are true. So if I try to print condition 3 here, so both of these are true. So this is also true. And if I make any one of them as false, so let's say if I say a less than 0, it is not less than 0. So now 1 is false. So this is true, this is false. So combination is false. So that is how AND works. Simply putting, what it means is that we will get true when both are true. If any one is false or both are false, we will get false only. That is how AND works. And currently it may be slightly confusing also. That is also fine. This will make more sense when we later on bring some complex scenario and then combine conditions. But these are the different operators we use to like combine different conditions. And similarly, we have a OR operator. So this is different from AND. OR means if one of this is true, we will get true. So if any one is true, so let's say in this case, one is true, one is false. So we get true because one of this is true. So that is how OR works. So if one is true and both are true, we will get true only. Similarly, we have this note. Note is like a just to reverse the condition. So if I say condition 1 and if I say note, so it will reverse whatever is there in the condition 1. So if I run it now, so condition 1 is true, so note will say false. It is used to reverse the condition whatever it is. So this is a operator I wanted to explain, and depending on the real life use case, we use them accordingly. And then we have some assignment shortcuts as well. So we have a shortcut like plus equal to and minus equal to. And what I mean by that is, let's say we have a number, so we can call it as score. Its value is 0. So assignment means like we have assigned this as 0. So this equal to is called as assignment operator also. And now let's say I want to increase this score by 5. I have this typo. Let me correct it. So if I want to increase its value by 5, so by default, what I will say is score equal to score plus 5. And then I will print the score. So if I run this, it will print like 0 plus 5, 5. So what it means is that take the value of score, add 5 to it, and store the new value into this score variable again. So it will print 5. So whenever we come across any such scenario that we need to add or subtract into the same variable, then we have a shortcut as well. So instead of writing this complete sentence, simply like we can use this plus equal to. So it is nothing but a shortcut of the same thing. So when we say plus equal to 5, it will do the same thing. Like take the same variable, do a plus of 5 and then print it. And similarly, we have a minus equal to also. Let's say if we want to start with 5 and we want to, let's say, subtract 3 here, then we have a minus equal to as well. So both kind of shortcuts are available. And these are called as assignment shortcut. So whenever we want to increase the same variable or decrease it, then these are used. And then comes some like underlying memory related concept, which is a same value or same thing. What I mean by that is, so let's say if I create a variable, let's say anything, let's say number 1 again, we give it as a 1000 value. And then I create a number 2 and I say we give it a value as 1000 again. And then if I compare these using our normal comparison, saying that not print, number 1 equal to number 2. So here it is like we are comparing the value of these two numbers and value is same. That is why it is true. But underlying like internally within Python, what happens is that it will create one variable into memory. There it will store 100, this 1000. Then for number 2, it will create another variable. It will not refer the same variable. It will create another variable. There also it will store 1000. So these are two different variables and their values are different. So what we mean by that is, so to confirm that underlying memory wise also, is it the same variable or not? Then we have another operator which is called as is. So number 1 is number 2. What it means is that our underlying a variable or the memory storage also same or not. So here we will see false because underlying memory is different. We created these two times and they are two different variable whose value is same but underlying objects are different. And let's say if in the code we put something like this, now it will assign this number into this another variable, and if we run this way, now we will get true. So now how it is that now it knows that number 2 is also like pointing to number 1. So instead of creating another memory, another instance, it will simply point to the same instance. So we can both have same value and both are underlying also same. So that is where we need to be careful while using equal to or is. Equal to, just compare the value. Is confirm whether actually also those are same thing or not. That is why we call it as like whether it is same value or same thing. And that is how we can confirm it. So this is all about different type of variables, comparing them, and then converting their values and everything. Now here we have a very simple and small exercise. Let store a price and a quantity, calculate the total cost by multiplying them, and then print a message whether the total is over 50 or not. So these exercises are also like important once you understand all that these theoretical pieces, and then or like do a hands-on one by one. Then in this exercise you will be able to combine those things and write a like very simple and small program to again confirm the understanding. So let's say here we are saying that we want quantity equals to 5, and then we want a price. So let's say price is 2 here. So these are two variables, and now we want to calculate total cost. So let's say if we say total cost, we what we want is we want their multiplied values. So quantity multiplied by price, so that will become our total cost. So first, let's confirm if this is working fine. So we will print this total cost. It is 10. Their multiplication is working fine. And also we want to say whether the total is over 50 or not. So how we can confirm it? We need to use a condition. So we want to confirm if total cost is greater than 50 or not. So that is where this greater than the logical operator comes into picture. So this will confirm if the number is, sorry, the total cost is greater than 50 or not. False means it is not over 50. But if let's say the quantity it has been increased to let's say 30, then it will become 60, it will become greater than 50 and it will print true. So that is how like we can combine all these different operators. So in this exercise, we have understood all the different types of variables that we can use, how we can check their type using the type variable and convert the types if required. We also understood how we can do arithmetic operations, how we can compare different variables, and how we can combine all of them. We also see the assignment shortcuts and comparing the actual value and the actual object as well. So now as we understand like the core functionalities in the Python, like the core, again, very basic functionalities, and we understand how it is executing. Now is a good time to really understand how internally it is working and how does Python it compare to other languages also. When we are running our Python program, so it is running on something called as interpreter. So for any programming languages, there are two famous ways to execute any code. One is called as interpreter and another one is compiler. So interpreter, what it does is whatever code we are writing, it will read the code line by line and it will keep executing on the go. Maybe if we are starting something nested, maybe it can wait for a couple of lines, but the overall like it will keep executing the code file by file and in the flow. That is how an interpreter works. And when interpreter works, it will actually read like one line at a time. Maybe if it reads some line, it may wait for next line depending on the type of the line, but it will go line by line, it will understand, and then it will take the action and provide the output. That is how an interpreter works. It doesn't need to understand entire code in one go or generate something intermediate. So that is how like it simply read our file, work line by line, and provide output. And when we installed Python, that time under the hood we have installed Python interpreter. That is how we say it. There are other languages apart from Python also which use interpreter, like their own interpreter, like JavaScript, Ruby, PHP, and all. And other way to execute program which is not used by Python but it is also very powerful and strong. This is called as compiler. So when a compiler works, what it does is, instead of executing the code line by line, it will take entire program. It will take entire one file or the set of multiple files. It will do all the important checks and it will convert those files into a executable code. And that will be like that code we can't directly read it, that can be read by machine or the program itself, and then that code will be executed. It will be ready to execute, and that code it will execute entire code in one go. So this kind of a mechanism is done by a compiler. It kind of translates our entire program into a machine code before executing it. And then when we are ready, then we can take that executable code and then run it. So that is a compiler type of execution. So the programmings like C, C++, Rust, and Go, those use compiler under the hood. And there are other programmings like Java, C Sharp, and others. Some use hybrid approach as well. They compile the initial code into some machine level intermediate code, and while executing, they run that line by line. So a hybrid approach also exists. So these are, I would say, different two different mechanism of executing any code. And why there is this big approach difference is that, or you may think why anybody would want to convert it when we can simply execute it line by line. The answer to that is speed. So if we have compiled our code and then if we run the code, it will run very, very fast. So I have seen like some practical examples in my projects where if I write some program in Java versus Python, the Java program will run more than 10 times faster than Python. So that is where interpreter, those are slow to execute. Compiler are those are very fast. But setup wise, interpreter is simple. Compiler are slightly complex than interpreter because they need to compile and build one file. Then that file will actually run the code. So that way, these are some pros and cons, and that is where Python focus here. It is not the a complete speed. The main focus is simplicity and readability. That is why it is best out of interpreter. And there are some cases where if speed is required, there are programs or softwares which can convert this to a compiler code and then run it. Those kind of things are there. But for general use cases, wherever we need to write a script or a normal program where let's say the we don't need to do very, very heavy operation, there Python can still work. And there are a lot of optimizations done within Python as well. That way its speed is increased. But any language running on interpreter, it can never match the speed of compiler. So overall, interpreter based languages are considered as slower than compiler, and Python, it runs on interpreter. So now I hope you understand under the hood how Python is working. So now let's go ahead to the next exercise. So now I will go ahead and open our third Jupyter notebook. And here you can see an image as well. So this is also part of Markdown. So in Jupyter notebook, how it works is if I double click this one and click on edit thing, you will notice this. So it is a path that is mentioned here, like images and then this. So in the images folder, I have created these images. This is the actual image. And here it is like, it is simply displayed here. The actual image is not here. So that is how Markdown works. You don't need to worry, but only for knowledge, I was telling it. So now as we understand the core variables and everything, so the next thing, it is about making decisions. So if we have to make some decision, like if this happens then do this, if this doesn't happen then do this, those kind of things we call them as conditional statements. So let's understand these conditional statements one by one. So we have these three types. One is like simple if condition. So this one, it will execute a block of code if the condition is true. So how the flow works is, we define a condition. That condition will return a true or false. If the condition is true, it will execute the code inside that. If the condition is false, it will skip that code and not execute and go to the next step. So this is a simple thing. Let's say if condition is true, execute that. If it is not true, then don't execute that. So for this, we use that. And to build these conditions, we use these different operators that we already saw. So these are all the logical operators. Like if we want to see, if we want to run, let's say if that variable is greater than 5, then only run this, then we use these operators. If we want to combine multiple conditions like we saw in previous exercise, then we use these, let's say and or not. In these are different logical operators that we can use. Is and all, I know I didn't explain is and in, those it will come later on. But yeah, that is how if condition works. And if we want to add one more complexity, where we say that if this condition is true, then execute this code. If this is false, then don't execute this code but execute another piece of code, and then go to the next step. So in both the conditions, if we want to execute something, then we use if and else. So programmatic wise, this is how it works. If it is simple condition, we mention the word if, then condition, then the code to execute. And in if else, we say if is same as previous one, and we specify else, and then we specify the code that we want to execute if the condition is not met. And then let's say if we want to combine multiple conditions step by step, let's say first check condition 1. If it is true, do this. If it is not true, then check another condition. And then if that is true, do this. If that is also not true, then check another condition. Likewise, we can combine multiple conditions. And if none of the condition is true, then do this. So this is called as if else ladder. So this kind of condition can be set up by this. So instead of simply using if and else, in between we put elif, elif, elif. Elif means it is else if. This programmatic piece you will understand more when we go to the exercise. But these are the simple conditional statements that we can use a simple if else, or a if else ladder. So now let's go ahead and build all these one by one. So now I'm back in our notebook, and this left section I will minimize it so that it is more readable. This piece we have already understood. And now let's start here. So first, let's understand, let's say the task here is that store an age in a variable, then print you can wait if the age is more than 18 or above. So that is the simple task here. So we take a variable age and we take its value, let's say 20. Then we define a condition. So condition we need to start with if, then we mention our actual condition. So condition is age greater than 18. Is it greater than 18? Then do this. So after this condition, we need to use this colon. So this colon, it means like now the condition that we wanted to define, that is over now. Then in the next line we need to mention like we need to simply print let's say here maybe we want to say like you can vote, like you are eligible to vote if your age is greater than 18. That is what we are saying here. So if I run this, I need to select this kernel here or the environment here, and now it is saying you can vote. So because value is 20, 20 is greater than 18, it is saying you can vote. But if we take any less value, let's say 10 or something, then it will not print it. So now the execution is complete, but because this condition is not met, it is saying, it is not saying anything. it means like this piece of the code execution, it is skipped in this case. And now let's say if we want to say that if age is not greater than 18, then print you cannot vote. So that is where we will use the else. But before we go to the else part, we need to like understand something called as indentation. So the name may sound like a strange name in the very first time, but it is very simple thing. So indentation, it means the alignment of the lines. So here, this print, if you noticed, it is not starting here. Let's say it is not starting from the very first line. It is if I remove that space or something, it is saying error. It is a note and like indentation. If I put a space, the error will go away. If I put a tab, the error will go away. What it simply means is that if we are defining a if condition, then this print statement, it is inside this if condition. It is not outside. Similarly, if I let's say go to the next line, and let's say here if I print let's say hello, so this is also inside if condition. And if I like come to the very first line here, and if I print let's say out, so this is outside if condition. So to decide if any block is inside another block or not, we need to shift the indentation to the right. So if I run this piece of code, we will notice that in this case the condition is false. That means these two lines are not executed because these are inside this if condition. This is executed out because this is outside the if condition. So this is how Python knows if some block of code is it inside another block or is it outside. So if we shift anything to the right, it means that we are saying to Python that this piece is inside the other block of the code, which is like to the left. So aligning this properly, like whether something is on the left or side, right, or starting with some space, this is called as indentation. And why you may think, right, this seems very strange. So before like Python or other languages, what they used to do is they used to use this kind of brackets, like to define like something is inside or not. So here this way the code did not like look really readable and everything, it seemed strange. That is where the people who created Python, they came up with this indentation so that we don't have to specify those brackets and everything, and this way it can know if something is inside another block or not. So that is how like this indentation works, and that is how like this alignment also matters a lot. So if I the way I was removing this space from here, so now Python thinks that there is nothing inside if, because this is outside if, so it is throwing an error that it is not indented properly. So that is why it is very important. So these two items we have already cleared in our explanation there about indentation. And now let's come back to our else condition. So here we were saying like if age is greater than 18, we can vote. So if we want to put a else block, that if it is not greater than 18, then we need to put a else block. So if I press enter here, I need to press backspace so that else I can put here, because else is not inside if, it is outside. So in the else we don't need to specify any condition, because condition is already there, it is just the else part. So if I say print, we are saying that you cannot vote. So if age is greater than 18, it will say you can vote. If it is not greater than 18, it will say you cannot vote. So that is how if and else they work. If the condition is met, do this. If condition is not met, then do this. That is how it works. And then moving to the third level, where like we need to combine multiple conditions. So let's say we have a task here where we have a score variable, and if it is value is 90 or above, the grade shall be A, it shall print A. If it is let's say 70 or above, it shall say B, and for anything else it shall say C. So if this kind of condition we have to build, then how we will build is score. Let's say we are taking it as a variable. By default, let's say it is 92. So we are saying if score is greater than equal to 90, then do this. So then print a. Print a. A means like I'm putting it in double quote so that it is exactly printing a. And then we are saying if it is not greater than equal to 19, then check another condition. So that is where if is there. Then we are saying then check if score is greater than equal to 70 or not. If it is greater than 70 or like 70 or above, then we are saying like print b in this case. And if it is not greater than 70 also, then we are saying in the else condition. For everything else, we are saying print C. That is how it will work. So this is how we are combining multiple conditions here. So this time this condition is checked. It is true. It is printing A. If it is its value is like 80, so it is checking this. It is not meeting. It is checking this. It is meeting. So it is printing B. And if it is something, let's say 60, then both of the conditions are not meeting. It is going here and printing C. So that is how we can combine multiple conditions using this if else ladder. So now as we understand how to make decisions, the next thing we will understand is how to do something repetitive task or doing the same thing many times. So for example, if I take something very simple, let's say if you need to print, let's say my name 100 times. So one way is just use print Narender 100 times, but that is not logical, right? So to do anything repetitive, we have these functionalities in Python and in every programming language. Those are called as loops. So there are two type of loops we can use in Python for two different purpose: for loop and while loop. So let's understand these. So let's say if we have some use case where we want to do something like a definite number of times. Let's say if we have some list, let's say apple, banana, cherry, we want to simply print their names. So we know that it has three items, we need to print them one by one. Or the use case I was talking, right? If I want to print my name 100 times, so we know in advance that we are trying to print something 100 times. So we need to go 1, 2, 3, 4 up until 100. So in advance, if we know what we are doing and we need to do the same thing or similar thing one by one, we start it, we do something in sequence, and if there are more things to do, we keep doing until we complete everything and come out. For these kind of use cases, we use a for loop. And let's say in advance if we don't know how many times we have to do something, but the use case is like we want to do something until this thing is there, any condition is there, right? So we want to keep doing something until some condition is matched. We don't know how many times we will do in advance or something. Then we use a while loop. So while loop is like it will check a condition. If it is true, that means we need to do that thing again and again. So it will keep doing the thing again and again until the condition is being met. Whenever the condition that we are setting, if it is not meeting, then it will come out. So if it is confusing for you, it is totally okay. You will get it more when we go to the real example. So now I am back in my notebook, and for your reference I have put these images also in the notebooks only, so that you can understand as and when we are going through these. So here we will use a for loop. So the task here is that store a word, use a for loop to print each of its characters. So again, let's take something simple. Let's say I'm taking my name here, Narender, and what we are saying is that for, let's say ch is for, let's say, character in name, and then the for condition is ending here, and then we are saying like print ch. So what it is doing is that it is taking this name as a string, and it is taking character by character, and then it is printing. So this is how a for loop will work, like for, then the condition or the iterator, like we need to iterate something over some list or something. Here we are iterating over this string one character at a time, and then printing that character one by one. So this loop, it will run 8 times, and for each character it will simply print it. So that is how a simple use case of for looks like. And what we are putting in this here, it can change like depending on the condition or what we are trying to do. There are different things, but this is the simplest example of a for loop. And then uh, very frequently we use something called as range with for loop. So range, it is a function that is ready to be used in Python. This creates a sequence of numbers that we can loop over. It by default it start from 0, and it can go to any number that we want. So for example, if we want to, let's say, print some number from 0 to 4, so how we will do is, we will say, let's say, for number, a number in a range, and if we specify, let's say, 5, so then if we try to print the number, then yeah, I forgot to put the bracket, and if I run it, so you will notice that it is printing 0 to 4. So 5 means it need to it will provide 5 values. By default it will always start from 0, so 0 to 4 it will provide. So that is a range. So if we use 100 here, it will print the numbers up to 100. So that is why, like, generating these numbers dynamically, this range comes very handy. And like, we need minimum one parameter here, and let's say we don't want to start from 0, we want to start from 1. Then what we can do is we need to specify that as well. Let's say 1. Then if we specify 1 to 5, by default it will print 1 to 4. Like, it will stop 1 before here. This is the end, and it will stop before end, and it will start from this. So 1 it will start. So if we want to print 1 to 5, we will use like 1 and 6. Then it will print 1 to 5. This is how we can use a start and a end here. And if we have some use case, let's say we want to skip some values in between. Let's say we want to go from 1 to 3, 3 to 5, skipping in one value in between. Then we have a third parameter here. So let's say if I'm specifying 1, and here let's say we are going until 11, that means 1 less than 11, and we want to skip, let's say we want to increment by 2. So if we run it, what it means is that it will start from 1, it will increment by 2, so 3, again increment by 2, again increment by 2, until this end is reached. So that is how, like, we can also control what shall be our step size or increment size. So that is how, like, this range, it comes really handy whenever we want to do something repetitive any number of times. And remember these parameters. So default is single parameter, start from 0, and it goes to that value, 1 less than that value. And if we want to specify some particular start, we can specify step size also, we can specify. So this is how we can use for loop. Next, let's say we are trying to build something using while loop, where let's say we are storing a value is let's say we are starting from 0, and we want to keep increasing and printing it until, let's say, its value is less than 5. So we are not saying you shall end at 5, you shall end where. We are only saying you keep increasing it one by one, and then keep increasing until its value is below 5. So for those kind of conditions, what we do is we use a while here. So we are saying while number is less than 5, then do this. Then what it will do is, we are saying then let's say print the number here, and then we are saying that increase the number by 1. So we, if you remember, the plus equal to 1, number equal to number plus 1. So here we are simply saying is that start from 0, uh, like while the number is less than 5, keep doing the same thing again and again until the number is like not less than 5. Then like keep printing the number and keep increasing it one by one. So if we run it, we will get the same thing, 0, 1, 2, 3, 4. When it prints 4, it increases this to 5. Then when it is checking the condition is not met and it will stop executing it. So that is how, based on a condition, whenever we want to do something, then we use a while loop. So let's say if the condition we had specified 10, so it will keep doing the same thing again and again until the condition is going till 10. So that is how we use a while loop. So this is how we use the for loop and the while loop. Now comes the next concept, which is called as break. So like if you are doing something again and again, we can press a break and then tell Python that yes, you stop here. So that is how we use a break. So simply we are saying like loop through the numbers 1 to 10, but stop as soon as you reach 6. So let me explain this by example. So let's say if we are saying for I in range, we are saying like 1 to 10, if we are trying to do, and simply printing, let's say I. So by default, what it will do is it will print 1 to 10. So now this loop is going like one by one, and it is keep doing a stuff. But due to some reason, let's say if we want to apply some condition, let's say if we are saying that if you reach 6, or if the value of I is 6, then you apply a break and you come out, you don't do anything. Then we need to specify it as a condition. Let's say if we are saying I is equal to 6, then what you shall do is you shall break. Break means break, it is a keyword that is there. So if I run this program now, it is going through the loop, and for each of the iteration it is checking this condition after printing. So once it has reached 6, it is checking this condition is true, then we are applying a break here. So then break means if something is met, some condition is achieved, then we apply a break and we don't do anything further. So to do this kind of thing, we use this break. And similar to break, there is another thing called as continue. So what continue means is that, let's say if we have some kind of thing here, let's say if we are printing this number, but if we are saying, if let's say the number is odd, then you do the stuff. If the number is, let's say, even, then you like don't do something in this iteration, and then you can continue to the next iteration. So for example, if I copy the same code, so you will understand more when I put this example here. So if I put this condition before here, like this. So now, right, we are saying like if we reach 6, then you apply a break. So now print is after this break. So after, during 6 also, it has applied the break, and this print is also not working. But now let's say if we are saying that if I mod 2 equal to 0. So what it means is that if we are saying whatever value is coming in I, if that, if we divide that value by 2, and reminder that we get, so divide is like this, which is used to divide the number. Mod or percentage, this is called as mod. What it means is that after dividing, how much remainder we are getting. So if it is a even number, it will be divisible and remainder will be 0. And if it is odd number, then it will not be 0, it will be 1. So here if we specify continue here, so what it will mean is when the value of I is 1, this is not true, so it will print that. When it is value is 2, 2 more 2 is 0, it is met. So this continue, it will skip this whatever is after the continue. That piece it will skip. Then it will go to the next value, which is 3. So 3, it will print. 4, it will not print and it will continue. So that is how it will work. So if we see here, like whenever it is odd number, so this is not true. So it is not doing anything. Whenever this is a even number, it is using this continue and not printing this. So that is how continue is used. But understanding the difference with break is important. Break means we apply the break, we don't do anything in the loop. We come out of the loop. Continue, what it means is that only this iteration, like if number is going one by one, only that iteration or that number we will skip whatever is after that line within the for loop. But it will go to the next iteration and then it will keep doing the same job. So that is the difference between break and continue. Continue means like in practical life we will encounter some things where if some condition is met, then don't do the rest of the stuff. If that is not met, then only do this and keep doing the main process again and again. Those kind of situations we will use continue. And now, as we understand this, our next, let's understand some placeholder in Python. So it is not specific to loop, but in general, anything. So we have this like keyword pass. Pass means like just pass through here, don't do anything. That is the only thing. And how it is used is that, let's say if we are using something, let's say number equal to 5, and if we are writing some condition, let's say if number is greater than 0, then we are saying, let's say here we are saying, for example, pass, and else we are saying uh, print, we are saying, let's say it is a negative number. So whatever is greater than equal to 0, like that is not negative, otherwise it is negative. So when we use passes, pass basically does nothing. Nothing means like in this case it will not print anything. It is a placeholder. So if we are writing a program and uh, if right now we are not sure what we are trying to do. So for example, if I don't want to implement here anything, else part I know I want to print a negative number. Here for now I just want to put some placeholder, and the code that I will use, the code, actual code, I will put it here later on. Then if you don't put anything, the code will not run. Python will be confused why there is nothing inside if block. But if we use this pass, it will know that this is for future use. For now I don't have to do anything. And this pass, it is not only to if condition, loop or anything. Wherever we want to create a placeholder just for future use, we use this special thing named as pass. So pass means it will do nothing for now. We will put the code later on in future. And now let's go to the next part. So as we have understood the core things about loops and conditions, so let's do some simple exercise which comes in different interviews as well, like printing stars. So what we are learning here is that loops can also be inside loops. And how it can be, let's say we have a requirement, we want to print these 3 lines of star, each having 4 stars. So by default, like we know we can use a loop here. Let's say for I in range, and if I say, let's say 1 to 5, it means like 1 2 3 4. So 4 I am getting, and then I want to simply say print star. So this is a simple for loop. So the star, it is a like string. So here sorry. So I wanted to like print it in a single line, but every time we print here, it will take it to the next line. So what we will simply do is we will create it as a variable. So first we will create a empty line, and instead of printing it here, we will simply say line plus equal to, and then we will say star. So it will keep appending star to the line. Then after we have gone through all the 4 iteration, then we will print the line here. So if we print the line, we will get our 4 stars here. If we want to put a space for readability, we can do that. So now let's say this is one line we have printed. If we want to do the same thing 3 times, so one way is to simply, let's say, copy paste the code 3 times and then we will get it. But this is not the logical way to do, right? So loops also, there can be scenarios when we need to run loops also multiple times. In this case, we want to do the same thing 3 times. So what we will do is we will simply create another loop. Let's say for num in, let's say range, and we want to do this thing 3 times. So we will say 1 to 4, and then what we want to do is we want to do this. So I will cut it from here and I will paste here. And if you remember indentation, so I need to press a tab here or space, whatever. So now this is outer loop. All these 4 lines are inside this for loop. So inside this for loop, we have another for loop, and this for loop, it has this line. So that is how it is working. So simply what it means is that this code now it will be repeating 3 times, 1, 2, 3. So if I run this code, I will get the same output. So this way, there can be loop inside loop, for inside while inside for loop. Depending on the practical use cases, we may need to do nesting of loops. So I hope like it is understood now. And these were all the concepts I wanted to explain in this chapter. So now let's do one exercise so that we cover all these examples and then we build something logical. So let's say we are starting with the task like store this text in a variable. Uh, then let's copy this. I just double click it. I'm copying this entire string here. And then I'm saying, let's say line equal to this. So we start with this. Then we are saying first using a for loop, count every character in the text. If you want to count how many characters are there in this line, so what we will do is like for ch in line, it will go like character by character, and we start here. Let's say count, we start with a count of 0, and then we say count plus equal to 1. So for each character in the line, it will increase the count. It will keep adding to the count. Once it has added everything, then simply we are saying we will print count. So what it will do is this for loop, it will go character by character. And every time it is going to the next character, it will increase the count by 1. So if we print count, it is coming how many characters are in this entire sentence. So now, then in the next part, we are saying do it again, but use continue to skip spaces so that the count exclude them. Let's say we have a requirement. We do not want to count space. We want to count everything else. So for that, we have this condition. Let's say if we are saying ch equal to, if it is a space. So this is a space. Then do what? Continue. So whenever it is space, it will not increase the count. And if it is not space, then it will increase the count. So this time we can see 30. So wherever it is space 7 times, that time it continued, it did not do anything. Otherwise, it did that. And now let's say further, what we are saying is that uh, use break to stop counting as soon as you reach the first dot. So let's say this is, let's say 2 sentences are here. We want to stop the counting whenever we reach this, let's say full stop here. So for that, what we will do is we will add another condition here. Let's say we are saying if the ch is equal to, let's say dot, then we are saying break. We are applying break. So whenever it will encounter this dot, it will apply break. Wherever it will say space, it will continue and not increase the count. Whenever both of these are not there, then it will keep increasing the count. So now we can say it is only 11. This is the characters and before this dot, and which are not space. So that is how, like, depending on the practical use case, we may need to use for loops, apply breaks, apply continue statements. So all these things we use in combination in real project requirements. So just to recap, what we have understood is we understood indentation, how important it is. We understood the if else conditions. We understood loops. We understood range, how we can go over different numbers, steps, and all. We understood while loop to run something until a condition is true. We also understood how we can apply break, how we can skip something using continue, how we can use pass as a placeholder. And we also understood how we can use loop inside loop. So I hope these concepts are clear. So you can take a break, you can do it yourself, and whenever you feel ready, we will go to the next chapter. Now let's go to the next chapter, that is about strings and text processing. So first let's understand like string. So this piece we already know how we can store any string. Let's say if we have a variable with the name, we can store any string that we want. Let's say hello Narender, and then we can print it if we want. So these text that we store, this is called as a string. And here I'm selecting the virtual environment to run it. So this kind of simple string, we call it a single line string. And then we may have strings where we may need to write something or store something across multiple lines. Because here, if let's say this is the string, if I split it into multiple line, so this way it will not work. So for that, what we need to do is like to store something in multiple lines, we have to like put this double quote 3 times. So this is a standard way to define any multi-line string. So between these like triple quotes, whatever we define, let's say hello Narendra, how are you? This is a multi-line string, whatever we want to try out. So now this will be considered this as a single string which is spread across multiple lines. So now this single variable, it is able to store this multi-line string. Then if we want to find the length of any string, then we have this function len. So simply if I let's say print uh, len of any string, let's say the string that is above name, so it will print the length of that string, like how many characters are there in the string entirely. And this string, it is stored a kind of a list of characters. So last exercise we see how we can iterate over a string and print each and every character using for loop. But let's say if we want to access any specific element based on the position, specific character. So let's say this is our name and we want only let's say first character. So for that, like this, we can specify the position in square brackets. So if I run it, it is printing the very first character that is there, like from hello Narendra, it is printing just the H. So this position, it starts from 0. So if I let's say put 1 here, it will print the second character which is there in the string. This way, using these index numbers, we can traverse through any of the string that we want. And if we want to start from the end instead of the beginning, so then like we can use a negative index as well. So for simplicity, like our visibility, I am putting it again here. So now let's say if I want the R from the end, so that one, how we can access is simply like instead of starting from beginning, if we want to start from end, then we start with -1. So -1, it means the very last character. -2, it will mean second last character. So that is how we can access character by character. And if we want a group of characters, then we can use the slicing method. So how we can use it? It is also the same thing. So here what we need to specify is from where we want to start and until when we want to go. So if I say 0 to 2, then yeah, sorry, it is not comma here, it is colon in the syntax. So it is starting from 0, and then here we are saying how many characters we want to take. So here if I say like say 0 to 4, so it will take 4 characters. And starting position also we can change here. So here in this case we are starting from 1 and we are going until 4. So 4 it is not the length. I think I tell it like in a wrong way. So 4 is the end position. Like we used to use in the range, it is very similar. So it is starting from 1 and it is going until 4 position, just before 4. So until 3 position. So like NARE. So the positions are like 0, 1, 2, 3. So just before 4 it is stopping. And similar to range, we can specify a step size as well. So let's say if we want to skip every alternate character here, so we can specify a step size as well. So n it it will start from 1, which is let's say a here. Then it will skip the r, take e. It will uh, skip the n and then take d, and by that time this end position has already been reached, so d is not printed. If I specify 6 here, then d will also come. So this is start position, this is like the end position. Before this it will stop. This is the step size, very similar to range. And then the next function that is there about changing their lowercase and uppercase of any string. So here we are saying that store the variable, let's say it can be anything, p equals to, in a store the value as Python. So if we want to convert it to lowercase, then we will say p dot lower. This is a function. This is how we call it. So it will be converted into lowercase. P becomes lowercase now. Similarly, we have upper, that will convert it to uppercase. So this is how we can change the case of any text or any string. And if we have any string which has extra spaces, so those we can remove using a function called as strip. So if this one it doesn't have any space, but let's say if we have any space at the start or any space at the end, so it will remove those spaces, and then the new value it will not have those spaces. So to remove those spaces we use strip. Uh, it will remove any space before starting or ending. And if we want to find some specific string inside the string, then we can use the find function. So here, let's say if we create this as a variable here, let's say its name is C, and it has these values. And if we want to find if this particular string variable, it has like a substring or somewhere in it, is it having, let's say, something like cats? So this is how we can search for. So within C, it will find if there is any cats or not. If it is there, it will return the position of that when that is there. So this is available at 7th position from start. So it is returning 7. And if we search for something that is not there, then it will return -1. So -1 means that is not found. So this is how we find anything. And if we want to replace what we find, then we have a replace function. So here, let's say instead of find, if we want to like replace something, so we use this replace function. And then first we specify what we are finding. Then we specify what value we want to replace it. So now the cats has been replaced with dogs. So this way we can find anything and then replace it with another string. And in the next step, let's say if we have two strings and if we want to combine them, then what we do is simply we have the plus symbol. We have already seen it before. So let's say we have two strings with the name. Let's say first name is Narender, and let's say a last name is Kumar. If we want to combine these two, then simply we need to use print. So print first name plus last name. So it will combine both of the strings. And if we want to include some more in between, let's say space or something, we can provide it as a hard coded or like string literal using double quotes as well. So it will put a space that way. And in the next one, let's see how we can build a string using f strings format. So this one, it comes really handy while printing like some very long or some detailed kind of strings. So let's say we have two variables here. So let's say name is Narendra, and then let's say age is whatever number we want to put, let's say 35. And then if we want to print, let's say print. So we already know like using plus plus we can combine different things. But if you have so many things, then putting that plus plus so many times, it becomes tedious and it doesn't look good. So that is where there is a different way. So let's say I want to print, let's say my name is, then I want to print, let's say name, my name. And then let's say I want to say I am is years old. So I want to use those variables and I don't have to use so many plus and break and everything. So for that, what we do is we have to specify those variable names into these curly brackets. So if we specify like this, and additionally what we have to do is before start of the string, we have to put a f. So if we put a f before this double quote, then Python will know that whatever we will put in these curly brackets, that is a variable, and I have to replace that thing with the value of the variable. So that is how we can use it automatically. So this is called as like f string formatting. So whenever we are building something very long or printing so many things, this can come really handy. Now the next one comes a split function. So if we want to split a big text into based on some character, like we can split it into a list. So for example, if we have this sentence, let's say I like dogs and cats. Then if we want to split it based on space and get each word separately, then we use the split function. So let's say we have this sentence, and then if we use split, so let's say sentence and then dot split. So what we will do is we will get each and every word separately. So this split, like we can store it into another sentence as well, sorry, another variable as well. For example, let's say if I say splitted, and then like we can print it, and also like we can iterate over it and do something. So for example, like this is doing the same thing here. And if we use our for loop, let's say for word in splitted, and then if we print them, then we will be able to like print each of them one by one. Okay, I made a typo, it is word. So we will be able to print one word at a time. So let's say if we want to split it based on space, then we can use it. And if we want to manipulate something like words, doing a word count and everything, we will be able to do it. And after split, it becomes a list, and we can do many more things with the list. We will understand like the list in next chapter, then you will get more idea. And by default split, it will split based on space. That is the, in most of the cases, that is good enough. And if we want to split based on our own character or our own like a symbol, then that also we can specify. So here for example, let's say if we want to split it based on s, then we can specify that. And now we can see it has splitted it based on the S. So whatever is before S and after S, those things it has splitted it now. And now I will change it back to default so that I can use it in the next cell. So the next one, it is about joining the list. So if we have a list of words and we want to again convert it to a single sentence or single string, then we have this join function. So this is also like pretty simple. So let's say if I say joined equal to, we need to first specify with what value we want to join. So normally we join with space, then dot join, and then the list that we want to join. So this way we will get our joined list again as a complete sentence or complete string. So now if let's say I print this joined, I will get my sentence back, the same sentence. And here by default, I'm joining it with space. We can use any other symbol also if we want. And if we do that, using that, it will join. So now it has put underscore in the place of space. So here we understood what all operations we can do on strings. Because strings we use almost in every project, and it is very important to understand all these. Now let's do a quick exercise so that we can consolidate these learnings and then use them in a simple use case. So the use case here is that store the messy text in a variable. So let's take this entire text as it is. And I will say messy equals to this text. So as you can see here, there are multiple spaces and all. So it is not clean. So then the first step is like remove the extra spaces from start and end using strip function. So we will say strip equals to messy dot strip. So this way we will get our stripped sentence. So if I print stripped here, we can see the beginning and end, the spaces has been cleaned up. The next step is like split it into a list of words. So now let's split it. So splitted equals to we can say stripped dot split. We will get the splitted one. So now we will go ahead and try to print this splitted list here. So now we can see it has splitted based on space by default, and we are getting each and every word here separately. And now the next step is join back the words together with a single space between them. So here if you notice, like we had multiple spaces in between also. And to remove those, like it's directly not easy. So but when we did a split over here, so wherever it was having multiple spaces, so that also it has splitted like considering a single space, and the extra spaces are gone automatically, we can see here. So now when we will join it back, we can get it back with a single space. So we will use this single space dot join, and then our splitted list of words that were there. So if we print this joined now, we will see a nice text now. So now we are getting a single uh, space in between. The next step is like make the result lowercase. So now we can say like lowered equals to join dot lower. So this way we will get everything in lowercase. It was lowered. So now we can see the sentence has been converted to a lowercase. And the last one, it is like replacing this word coding with programming. So then we can say replaced equals to lowered dot replace function, and we want to replace coding and this exclamation as well with programming. And then if we print the replaced, we will get the replaced one. So instead of coding, we see programming now. And the final one is like print the cleaned text and word count using f strings. So let's say this cleaned text, if we want to print, which is the final replaced, this is what we are calling clean here. So we will say print and we want to use the f formatting here. So I will specify f and we will say cleaned text equals to, and then we will specify the variable which is replaced. So we will uh, get it printed like this. So we used the f printing here. And similarly, if we have to print its length, so that also we can print it easily using like a similar f formatting. So if we say, let's say length of sentence equals to, and then our variable, and this time like instead of directly replaced, we will say length of replaced. So that way we will get its length. So length here it is 37. So this way, in this single use case, we combined all these learnings. So as a recap, we understood how we can uh, index these strings, we can slice them, and we can get individual characters out of those using index numbers, like we picked up the range characters. We understood how we can do lowercase, uppercase, strip, finding and replacing things. We also understood how we can join different strings using plus and format them using f strings, how we can split them and join them back. So this is all about this chapter. Now let's move on to the next one, which is going to be the most important and interesting section. So in the next chapter, we are going to understand different data structures, which are list, dictionary, and set. Whenever we want to store combination of different values, so there can be different use case and different requirement. For that, there are three different type of data structures which are provided in Python. So let's say if we have some multiple items and simply we are creating a list of them. So just think about creating a shopping list that is there. So if you are just want to store multiple items as a group together, so that is what we create it as a list. So a list, it is an ordered collection of items. It is mutable and allows duplicate values. So like it is ordered means like whenever we add a new item, so the order is maintained. Whatever we added previously, it will stay there, and new item it will go below like that it is having. And then this is how we create a list in Python. Simply in square brackets, if we specify multiple items to it, we can create a list like that, and we can access them using index like 0 position 1 2 3, like we accessed different elements of string as well. And it is mutable. That means we can change the list, we can add more items to it, we can remove any item from this. And duplicates are also allowed in this, so we can keep adding more items quickly, but duplicates are allowed. And then if we want to store something as key value pair, like let's say if we have an employee, so what is the name, what is the age, what is the city, so these kind of key and value pairs if we want to store, then we use dictionary. And here keys, those has to be unique and immutable. That means keys we cannot change, and we can add more keys and more values whatever we want. So whenever we want to store something as key value, then we go for a dictionary. And set, these are also like list of items, but these are like not ordered, and they allow only unique values. So duplicates are automatically removed if we try to insert them. So sets, these are, I would say, similar to list, but the only thing is that uh, these only allow duplicate, these does not allow duplicate values, and these are unordered. So simply putting, if we need a simple list of items where we can add more detail and duplicates are allowed, we go for list. If we need a list but it shall have only unique items, then we go for a set. And if we need something as key value pair, then we use a dictionary. So now let's go ahead and use all these so that we can understand these better. So now I am back into our notebook. So first one, let's create a list. So it is saying like store 3 fruit names in a list and then print it. So we will say simply fruits, and how we define is in square brackets. Here we simply need to mention 3 fruit names. So this is first item in the list. Then second one, let's say, can be banana, and third one it can be anything else like pineapple. So this is how we have created a list. And now we can go ahead and print this list, which is fruits. So it is asking me to select our virtual environment, and now it has printed. So this is how it is printing as a list. And in our previous chapter, when we use split, so this is how it was printing. So that was automatically creating list of words there. So this is how simply we create any new list. And if we want to get its length, then here also length function is allowed. So let's say if we simply print here, let's say length of this fruits. So we will get 3 because it has 3 items. So this length it is allowed here. And then indexing is also like available. So we have this 0, 1, 2, 3, that kind of indexing. So we can access its items one by one. So let's say fruits, and in square bracket, if we specify 0, we will get the first item. Similarly, if we specify 2, we get the second item. Sorry, third item. 1 we will get with 1. And if we specify 3, then we will get an index error because there is no fourth item in the list. This is a common error that may happen with the lists. And later on, when we will go to error handling, we will understand how do we handle these kind of situations. But we can use this kind of indexing to access any element one by one. And if we want to start from the right side or starting from the end, then here also let's say -1, -2, those are allowed. So if we want to access the last element, we can access with a negative number. And similar to strings, like we can use slicing also here. So let's say if we want first 2 items, then simply what we will do is we need to specify a starting position colon the length, how many items we want. So this way we will get another list with just the first 2 items. So this slicing, indexing, all this is consistent across Python. So same way it works everywhere. And now comes the function specific to a list. If we want to add a new item at the end of the list, then we use this append function. So we already have fruits. So we can say fruits dot append. This is the function we can use. And let's say now we want to add a date fruit here. So this will be appended to the same list. After that, if we again print fruits here, so we will get additional fruit in our list. And the next function, it is extend. So if we have two lists and if we want to combine them one after the other and get a new list, then like we use this extend function. So fruits we already have. So let's say we have more fruits, which is another list. And here, let's say we have orange, and then we have, let's say, cherry. So this is second list. And if we want to, let's say, add these more fruits to our original fruits list, then we will extend that original list, and we will extend by adding more fruits to it. So now if we print the fruits list again, so we will get these extra items from the other list like this. So this new list, it has been all the items of that list is appended to our original list now. And now the next function is insert. So it is similar to append. It will also add the item to the list. But insert, apart from the item that we want to add, it also take a position. So append, it will by default add the new item at the end. But using insert, we can specify at which position we want to add the item. For example, if we take our fruits list again, And then if we use the insert function, then here first we specify the index at what position we want to add, and then what item we want to add. So let's say we want to add apricot here. And then if we print our new list, the fruits list, the not new list, like the same list with this new item, so we can see at one position this apricot item has been added to our list. Now the next function is pop. So what it does is, if we have a list and if we use, let's say, popped item, so it will pick up the last item from from the list. So if we have this fruits list, and then if we say simply dot pop, so it will pick up the last element. But apart from just accessing the last element, it will remove that element from the list also. So if we just want to access and not remove, then we will use the index -1 like we saw. And if we want to from the end, if we want to access element by element and keep removing from the list, then we will use this pop method. So now if I print this popped item, and also if I print the same list again, so we will see that the cherry item from the end, it has been popped into this variable, and from the list it has been removed now. And if we want to remove any specific element, let's say banana, if we want to remove from this list, then we have a remove function. So we will simply say fruits dot remove, and then we will say banana. And then if we print our list back, we will see that the banana has been removed now. So this way we can remove any specific item from the list. And if we want to sort the elements inside the list, then we can use the sort function. So if we do a sort here, and then if we print fruits, we will get the sorted list automatically. So now we can see the list has been sorted. And let's say if we have some use case where we don't want to sort the original list, but we want a copy of the list which is sorted and do not want to change the original list, then we use the sorted function. So let's say if we have some list which says like numbers equals to, let's say we have 1, 2, 4, sorry, 5, 3, like that. And if I say, let's say sorted list equals to, then we use this sorted function that is called by taking the list as a parameters. So now if we print the original numbers list, we will get it unchanged. And if we print our sorted list, so this is, we will get a sorted list. So original it is unchanged, and now the new list, it has been stored as a copy of the original list which is sorted now. And by now you might be thinking like, why there are so many functions and do I need to learn all? So yes, we shall be aware. And list, it is list and dictionary. These are the most important entities in Python. Whatever program or project we will be working on, having more knowledge about these is really, really useful. So that is why I have decided to cover many functions related to list so that you are aware of all of these. So we have couple of more for the list, and then we will go to dictionary. So let's say if you want to reverse all the element in the list, then we will use a reverse function. So this is also a simple function, a reverse. So now the numbers will be reversed in the same list. Sorry, print I wanted to type. So now the numbers has been reversed in the same list. And let's say if we have some requirement uh, where, let's say we have a list numbers, and it is having, let's say 1, 2, 3, 4, 5. And what we want is, we want another list where we want, let's say the double of each number. Let's say we want to multiply each of the number by 2 and then create a new list. Or let's say we want to calculate a square of this, whatever can be the requirement. So if we want to play around a list and all the items, that is where we have something called as list comprehension. And comprehension, it is like a short form of for loop. So let's say by default, we will be doing something, let's say for num in numbers, and then we can access the num one by one and then print them or something. But in list comprehension, we get a shortcut. So let's say for this num in numbers, we can do the same thing here itself. Let's say num multiplied by 2. So this way we will get the new list with all the numbers multiplied. So let's say we can say doubled and then I assign it. So it will do the same thing. It will access each element from the list one by one. It will multiply each element by 2 and give us the new list. So it is like a short form of for loop, and this is what we call as list comprehension. So here if I print doubled now, so we will get our list only, but with double the values of the original list. So this is how we can use list comprehension as well. So why we use it? Like because it can save a lot of coding lines. With single line we were able to use a loop, multiply it, create another list. So that is where it can be really handy. And the next function is enumerate. So sometimes we have a use case where in a for loop or something, we want to go over each item in the list and we want its index number and the value both so that we can play around it to do something. So let's say if we wanted to like simply go over each item. So what we will be doing is, let's say if we have a fruit list, so we will say for fruit in fruits, and then we will simply printing the fruits or using it for whatever purpose we want to do. So like this, so we will be able to print each and every fruit. But now let's say we want its index number also while we are getting it, so that we can manipulate it however we want. So for that, what we do is we have this enumerate function. So this is like the name enumerate, and inside this if we provide our list here, so we will get both the index and the item. So if I mention index here, now we will get both the index and the fruit. And here if I simply print, let's say index as well and also the fruit, so both we will be able to print. So this way using enumerate we can get index and item one by one for each of the item. And next, and this is the last function related to list, I would say it is zip. So let's say if we have two lists, let's say we have one list with the is, let's say names, and the names are, let's say Narender, then another name could be, let's say John, another one could be let's say Vicky, and then we have another list, let's say is, and then this list is having, let's say is which is there. So now let's say age is having 21, 32, 43, something like that. Now what we want is we want a grouped list which has this name and age. Let's say Narendra 21 and then John 32 and Vicky 43. So that those are considered as single item. We don't have to use two list in that case. So whenever we need to combine one item from each of the list and corresponding items, then we have this zip function. So let's say if I do zip here, and then if I use this zip and I call it on the names and age. So now this new zipped list, it will be having the combined name and age. First, let's see if we can print it directly. I'm also not sure if we can print it as it is. Let's give it a try. So yes, like we suspected it, we are getting a zip object. So directly it will not print it. If we want to access those zipped items, then we need to access them like this. Let's say for name, comma is in, and then our zipped item, so that it can extract each of the item from the zip, and then we will be able to print them one by one. So here we can print, let's say, name and age. So if we run it now, so now we will get the zipped item. So now we can see that this is a single zipped list, I would say, which has both the name and age. So we can access them one by one. So this is how we can zip two two lists together and combine their corresponding items into a zipped kind of list. And next thing it comes is a tuple. So tuple, it stores several items together just like a list, but once it is written with round brackets and it cannot, the values cannot be changed in a tuple. So tuple, it is itself is not like a big, I would say, very huge concept. It is like a sub item within lists and sets. So here, when we stored name and age together in a zipped list, so here we have two items. So each of the item in this new list was a tuple. So this is one tuple, this is another tuple, this is third tuple. So we have this group of items, but these are the items which are stored in a list as a, let's say, fixed item, and these cannot be changed. We can remove these items, let's say, as a tuple. We can delete the entire tuple, add new tuple, but the tuple itself we cannot change it. So that is where to store group of items together, this is there is this concept of tuple. So let's say if we define the same thing, let's say name and age. And if we define, let's say, in square, in round bracket, let's say Narender, and then let's say 21. So this becomes a tuple. So if I print this, I will get it as tuple. So I will be able to print it. So this is kind of a group that we get, group of numbers or group of elements. And and this tuple, like the original tuple, we can never change it. So like in the list we can append more items, remove something and all, but in tuples we can't change the original tuple. If we want to do something, like we can add more item and then get it as a new tuple, but original tuple we can't change it. So for example, if we have, let's say, colors, and here let's say if we have uh red, green and blue. So these are three colors. So this is a tuple that we have created. And here, if I print it, I will be able to print it. Uh, okay. Now, if I want to add one more color, so I will say new colors equals to, and then we will say like colors plus we can add more item here. So we can add, let's say, yellow to it. And now if I print new colors here, Uh, looks like I made some typo error. So there is this specific syntax that by default this yellow is considered as a string, not a tuple. So if I put a comma here, then it will become a tuple. So these tuples, although we don't need to like normally add more things, but I wanted to showcase that it is possible. The normal use case for tuples is using these as groups. Whenever we are getting these as a response from any other operation, or we are trying to access, let's say, some zipped items, that is when we use tuples one by one as a group. But normally we don't manipulate them or change it unless like we have some specific requirement. So that is all about these tuples. And next comes the most important concept, that is about dictionary. So whenever we want to store something as key value pair, then we use a dictionary in Python. So let's create our first dictionary. So let's say we are creating a dictionary person. So to create a dictionary, we have to use these curly brackets, and then we need to define key value pairs. So let's say name here, then we need to give a colon and then the value part. So let's say name is Narendra. And then let's say again another key, that is age, and the value for age, let's say it is 21. So this is how we can create a dictionary. So here name and age, these are keys. And Narender and 21, these are values. This is a string value and this is a integer value. So now if we try to print this dictionary, we will be able to print what content it has as it is. As a key value only it will show. And the next one is getting a value by using its key. So this is the most common operation that we have to do in real projects. If we have a big dictionary and it has so many keys, so many values, so we will want to access any specific value based on the key. So if a person is there, based on the key name, we will want its value, whatever value that is there. So that one we can access it. There are two ways to access it. So the first one is simply, let's say, is using kind of a index there. So here if I specify name, then I will be able to get the name here. So this is one way. But there is a problem with this one that I don't like. If we specify some key here that doesn't exist, so there is no key name to here, then it will operation will fail. It will say that there is no key error name to, and the program will fail unless we have some exception handling that we will do later on. But there is a better way to handle such situation, and that is where we have this get function. So if we use the get function instead of that index way, so let's say we have this person dot get, and then I want the name out of it. If the value is there, we will be able to get it easily. And if the value is not there, then it will not fail. The program will not fail, but we will get a none value. So if you still remember the variable types, this is the special type which is none. None means it has nothing. So normally we use this get operation and then we apply a if else condition. Let's say if the value is none, then print some message that the name doesn't this name too doesn't exist in the dictionary or something, and if it is there then only we proceed further. So that is why like we always prefer using this get function instead of using this indexed with the square brackets, although both of them can be used. And the next operation is, let's say, if we want to add or change some value in our dictionary. So let's say this is our dictionary and I want to, let's say, add a new key value here. So that how we can do is, this is how like we could access it, like city, but this is simply how we can set it up. So let's say this is how we can set it up. Now city will be the new key and Delhi it will be the new value inside that dictionary. So this is set up now. So if I uh, print this person, so we can see now we have a new key value pair city and its value. And if we want to change something that is there, let's say age, if we want to change due to some reason, so that also we can do the exact same way. So let's say person and then the name of the key and the value. So now if I print it back, we will see the value it has been changed now. So if the key if it is already there, it will replace the original value with the new value we are providing here. If it is not there already, it will add the new value like it added the city. That is how it works. And in the next one, let's say we want to know what all keys are there in our dictionary. So that one we have this simple operation dot keys. So person dot keys, if we call this one, we will get all the dictionary keys which are there. And if you have guessed already, so we have a values function as well. So using that, we can get all the values which are there for each of the keys. So if we say person dot values, then we will get the list of all the values which are there in the dictionary. And the next one is, let's say if we want to get a one item at a time, and if we want to get all the key value pairs and then do some operation, so that one we can do it with the items. So how we can do that is, let's say for key comma value, in, then we specify our dictionary dot items. So these items, like we were discussing, so it will return one tuple at a time as key value pair. Key will go here, value will go here, and then we can use that one tuple at a time to print it or whatever operation that we want to do it. So if we want to access key value both and do some operation, then this is how we can do it, and we can access each key value one by one. And the next one is about nesting the dictionary. So dictionary can also have dictionary inside it as a value. So that like if we have some hierarchy, then also like we can nest the dictionaries as well if required. So for example, this was our original dictionary, which had, let's say, a name and age. And then let's say for for the third element, instead of saying simply city, now let's say we have address. And address itself can have, let's say, multiple things. So again, inside the outer dictionary, I am creating a inner dictionary. And let's say this address, it can have a city, and city it can have any value, and then it can have another key value pair. Let's say it could have zip, and it could have value of the zip as well, like that. So like this, we can even create nested dictionaries if required. So now we have this outer dictionary, and this is the inner dictionary which is there as address. And also, wherever you want, feel free to use the type function that we had discussed previously, so that whenever we want to know what kind of object it is, so here we can see this person, this is a dictionary that is there. So this is all about dictionaries that I wanted to cover here. Next, we will go to our next data structure, that is a set. So here we will start by creating a list. It says like we can create a list of fruits. So or we can create it numbers, anything we want. So let's say numbers. We are creating a list here first, not a set, just to explain the functionality of set. So let's say we have 1, 2, 3, 2, 3, 4, 5. So we can see 2 and 3 are repetitive here. And then if we uh, if we want, let's say, unique numbers, then what we will do is we will use this. There is a function also with the name set, and inside that, if we pass the list, then we will get these as a unique numbers. So the list, it will be converted to a set. Now you can see the curly brackets came automatically, not the square brackets, because it is a set now, and the duplicates has been removed automatically. And if we want to, let's say, know its type, so that also we can uh, confirm here. So here if we call the type function, we will be able to print its type as well. So this type function, I find it very handy. Whenever we want to know what type it is, quickly we can know. And if we want to create a set on our own directly, then also we can create it like a list. So let's say here, if we create like this, we can, this will be created as our own new set. And then with set also, apart from just providing unique numbers, we can also do some other operations. So one is that we can combine two sets and then create a new set, and from there also it will keep only the unique values. So let's say here we have set 1, which is having, let's say, 1, 2, 3, 4. And then let's say we have set 2, which is having the values, let's say, 3, 4, 5, and 6. So if we want to combine both the sets and create a new set, what we will do is we will use the union operator. So what I mean by that is, let's say this is our set 1, and then this is our set 2. So the union operator, it is simple. This pipe symbol is there, just this horizontal straight line. So if we use this union operator, it will provide a new set. We can like we can create it as a separate variable as well. Let's say set3, so that we understand that it is creating a new set. So set1, then union, then set2. And if we print set3, we will get it like this. And also, as we were discussing previously, the sets are sorted automatically. So here, although we were using this sorted thing, but let's say here if we had 7 at the start, and then if we are creating it as a set, then automatically it will go to end. So the set, whenever we create it, it is automatically sorted. And this helps the set also to include a new number, or to check whether it is already there, because it is already sorted. It can quickly check. That is why it can do that. And now in the next operation, let's say if instead of combining two sets, we just want what are the common items between these two sets. Let's say here it is 3 and 4. So how we can find only the common item? We have this another operation called as intersection. So if I say set 4 equals to set1, and for intersection, this is the operation which is there with the symbol and if I say set2, then we will get only the common item between both these sets. So now if I print set4 here, we will get only 3 and 4 which are common. And then there is this last option about sets, which is, let's say if we have some use case where I want the items that are there in set 1 but not in set 2. Let's say these are common, I want only 1 and 2, so that I can know these exist only in set 1 and not there in this set 2. Then we have this simple minus operation. So let's say set 5, if I say set1 minus set2, then we will get that result. So if I print this set5 now, we will get only 1 and 2. So if we have some use case like this where we want element from 1 which are not there in second, then we can use this minus operation as well. And this covers all our main concepts related to the data structures. Now let's do a exercise so that we can combine all these, and then we can understand like with a use case how these can be used in a combination. So the task 1 is store list of names and matching list of countries with some countries repeated. So let's create a list of names first. So names, and list we create using square brackets. So it can be, let's say Narender, then let's say John, and then let's say Vicky. And then we can create another list with the name countries. And here, let's say countries, we are saying India, then let's say USA, and then let's say again India. So this is our task 1. Now 2 is use zip to build a list of dictionaries, one per person, each with a name and a country key. So this is something new we will build. So we can even create list of items, simple items, and even we can create list of dictionaries as well. So let's say the new dictionary we will, sorry, new list we will call it as records. And first we will create a empty list here. This is blank. And now zip function, you if you remember, so how we will use is for, let's say name, comma, country, in, we will use zip these two together, and then we will say names and then countries. And before we do something, let's print it one by one so that we can know if it is going as expected or not. So now we are able to print each name and country. So now what we will do is we will say, let's say new dictionary, and that dictionary we want to create it as name is the key, and then value we want to create it as the value of this name variable, and then comma the second entry as a key we want is the country, and value of country we want the value of the country variable. So this will be created as a dictionary. So if I print this new dictionary here, so for each and every entry it will be printed. So now we have created these three dictionaries, and if we want to create a list of these dictionaries, then how do we do it? We have this records, let's say records dot append. If you remember append function in the list, so we can append anything in a list. So it will keep appending it. And once we are out of the loop, then we will try to, let's say, print all the records. So it has appended all these three dictionaries into this records list, and this is what we get. So this is a list of dictionaries. And I would say this is one way to do it. I wanted to explain it one step at a time, but we can use like comprehension as well to make it very short. So if we had to use the list comprehension, how we would do is, so if you still remember, we need this like for thing, and then we want to put it in a list. So for that, what we want to put in a list, this new dictionary. So we will put it here like this, and then this entire thing we can put in a list like a square bracket. So then it will become a records, let's say new. So this will also do the exact same thing that we did here. So here you can see we wrote 3 lines of code. Here we wrote simple single line of code doing the same thing. So here also it will pick up name and country one by one from this zipped list, and then it will create a dictionary one by one and create a new list of those dictionaries. So if I print here this records new, we will notice that we are getting the exact same thing. So this is how we can use a list comprehension, and it can come really handy. Now we are done with our task 2. Task 3, it is like pull the country out of every record into a list and then use a set to find unique countries sorted. So we have like this list of dictionaries, and from this we want list of all these countries. Let's say we want this India, USA and India. So how we will do it? First we will need to, let's say, go record by record. So let's say for record in records, and then this time I will use the list comprehension in advance. So now let's say from each of the record, I want the country value. So I will specify like this. So I will get the country, and then I will attach it to a new list called as countries, let's say new, because we already have a list with the name countries, and then this square bracket. So this way I'm going over this dictionary item by item, like record by record, and from each of the dictionary I'm picking the country based on the name of the key, country key. Whatever values are there, those values will come up here, and we will get them as this list of countries. So if I print, we are getting this uh, list of countries here. So we have got it as a list. Now the next task is, let's say, to get unique countries. So let's say unique countries. So we will use the set function. So if we pass here the countries new, and then if we try to print the unique countries, then we will get only the unique countries, and we are getting it as a set, and it is sorted automatically. So this is our task number 3. Then the last one is that enumerate, use enumerate to print each person's record with a number in front of it. So what we need to do is we want to use enumerate over that. So we will say for, And if you remember, using enumerate, we get the index and value. And then we will say in, we use the enumerate function over our records. So this way we will get the index number and the value that is there in the records list. And then we can print here the index and the value both. So if we print it, we are getting this index as 0, 1, 2 because that is a list. At 0 position, this record is there. At 1 position, this is the record. And 2 position, this is the record. So this is how like we combined all these data structures, for loops, comprehensions, everything to solve one use case. But this is how like in projects we use them in combination with each other. So just to recap what we understood the list, how those work, all the functions related to it. We understood list comprehensions, enumerate and zip functions. Tuples also we understood that it can store multiple items which cannot be changed. Dictionaries, key value pair, we understood how we can use get keys, values, items, all those things. And sets also we understood that stores unique ordered items, and that supports like union, intersection, and difference methods as well. And about these sets, like officially we say these are unordered. So the order that we saw here, that like it automatically sorted the items. So that is a normally that behavior is there, but that is not guaranteed. So if you want guaranteed sorted items, so always use the sort or sorted function. So that is what the recommendation is. But in most of the cases, it uses the sorted, and normally we get the unique values. So that is what is more important while using sets. So that is where like when I explained, I think I told like these are sorted, and in the definition you may see unsorted. So officially it is unsorted, it is not guaranteed. But normally when we use it, we will see many times that it is sorted automatically. So now is the time to move on to our next chapter, that is about functions and reusability. So now, as we have understood overall, like how things work, what all structures are there in Python. So now we will understand how we can create some reusable code and how we can like use the same code again and again by creating functions. So let's start by defining a very simple function. So task here it is that call the here one cell was hidden due to some reason. So I unhide it, and this is our first task, that define a function. So define a function called greet that prints hello. So how do we define it? We use this keyword diff, and then we put the name of the function, which is greet, and then we use a colon saying that we are going to the next line, and this is the body of the function. And here in the body of the function, we simply want to print hello for now. So if I run it, if I select this virtual environment, you will notice that there is no print statement. And why is that? Because here so far we have only defined the function. The body of the function will be executed when we actually call the function. So let's say if I mention here greet and just this blank, now I'm calling that function, and then the actual body of the function that will be used, whatever that is. So the same function we can call however how many times we want to call it. So that is how like we define and use the functions. So every time we call the function, the body will be executed. So why this is useful? So that whatever logic is there, if we put that into a function, so we can reuse it and use it later on again and again, however times we want to use. And we can modularize the code as well. The functions we can store separately, and then we can call them from wherever we want. So from reusability and from modularizing the code, using the functions is very important. And this calling the function many times, we already see that. Next, let's understand how we can pass a parameter as well. So in this function, we simply like simply like printed hello. But let's say if we want to pass a parameter and then use that parameter inside the function. So for that, simply we specify the name of that parameter. And let's say here we can say then plus name. So it will print that name that we are passing. And while calling the function, we will be able to pass the name of the parameter as well. So let's say here, if I pass Narender, so what it will do is it will pass this Narender value to this name variable or parameter. Then the value will come here and it will be printed when we call the function. That is how it will work. So now we are able to pass that parameter. And we can also pass multiple parameters as well. So now let's say if I use this same function, and apart from name, if I let's say I want to print age as well. So here we can say let's say plus, and then we can say let's say I am, or like to this kind of use cases, let's say we use the F formatting as well. So let's use that. So we can say, let's say name equal to then the name of the variable, and then we can say like age equals to the value of age variable. So this is how we can define it. And here we can pass the age as well. So this way we can pass multiple parameters also that we want. And so far we have understood how we can pass something, but there are cases when we would want some value back from the function as well. So let's say if we are creating some function, let's say add numbers that can take two numbers and it shall return the sum so that we can use it. So let's say we have this function, let's say diff add numbers. It take two parameters a comma b, and in the function, what it does is it create a value as c, that is a plus b. It do a sum of two functions. And then if we want the value back from this function, so we have this statement return and then whatever we want to return. So this way we will be able to get our value back. So we will say, now we can say like sum of values equals to, we will call our function now add numbers, and we will pass these two parameters, and then we will get the value back into our sum of values. So like this. So if I print it, so now we have created this function that take two parameters and it is able to do some operation and return a value also back that we can use. So whenever we call the function, so using this assignment operator, we can receive the value back and then use it whatever we want to do. And while passing any parameter, we can provide any default value as well. So let's say if we create our greet function, or let's say here, so if I say, let's say greet default, and then let's say name is the parameter that we are taking. So here we can give it a default value as well. So let's say default value, I am giving it as a friend. And then here I want to print, let's say hello. And then I want to print, let's say name. So what will happen is, let's say if we call this function now, let's say greet default, and here if I pass my name Narender, so it will work normal as the previous function. Yeah, looks like I missed this colon here. So it will work a same as the previous one. But if let's say I don't pass any value here, then what will it do is it will take this as the default value and it will proceed with the execution. So this way we can set any default value that will be used whenever there is no value passed for that parameter. And overriding the default value, that is something we already saw, like while calling the function, if we pass something, so that value will be overwritten with the default value. And while calling the function, that time we can provide name of the arguments as well. So let's say we had this function greet, which was using, let's say, name and age. So let me copy this for reference here. So we have this, let's say, greet, maybe we can say with age. We can give it another name, and this is the same thing that we are calling here. And while calling this function, there is a way we can pass the name of the parameters as well here if required. So this is something optional if we want to do. It is doing the same thing, that name is being passed as Narender and age as 21. And in this way, we can even reverse the order or change the order as well if we want. So like this. So if we are providing the name, then even though we are providing them in the wrong order, then also it will be able to do the same thing. But if we are not using these names, then we need to provide the arguments in the same order whatever has been defined while creating the function. And next, let's see how we can pass any number of argument. So instead of providing this static number of arguments with a name and everything, there is a way how we can pass like the number of arguments dynamically as well. So there are both pros and cons. Let's check it out. So let's say let's define a function diff add all, which can take like any number of arguments. And how do we do that is using a star. So if I mention star numbers, it can take any number of numbers as input. And what we want to return is, let's say, sum of these numbers. So sum, it is a mathematical function that is available in Python. It will provide like sum of all the numbers in the numbers list. So here if I call that function and print its value, let's say if I'm calling this add all, and if I provide 1, 2, 3, 4, then it will be able to do their sum. So here we passed 4 arguments. And then let's say if I additionally pass 5, that also it will take it, and then it will be able to use it. So this is a way how we can pass, let's say, any number of arguments dynamically. And if we want to provide a name also to each of the argument that we are passing dynamically, that is also possible. And then that how do we do is, let's say we define a function. For example, let's say show details. And then here we want to pass the named arguments dynamically. Then we use 2 stars instead of the 1. So details is the argument, and double star means it can have any number of argument with a name and a value. And how we will be able to access them. But before that, let's say how we will pass them so that you understand how we will use them. So print, and then if we are calling, let's say, show details, and here we are passing, let's say, name equals to Narender, and then let's say city equals to Delhi. So this way I can even pass more and more parameters. I don't have to provide a name here. And how we will receive these is, if you notice, like these are kind of key value pairs that we will be receiving here. So here we will use that same thing that we used to access like key and value in dictionary. So key value in the details dot items. Using items, we get the dictionary items from the dictionary. So that way we will be able to access them. And here, let's say I want to print key and value both. And here I don't need to put print because we are already printing it inside the function. So this way, if you see, we were able to pass 2 parameters here. And additionally, if we pass some more, let's say if I want to pass age and value as any value, then that will also be accepted dynamically. So here, okay, I put a colon here. It shall be a comma. It shall be a equal to symbol because it is a argument. This way it will work. So this way any function can accept any number of argument and any number of argument with name as well. And now, as we understand everything about passing arguments, next let's understand about creating variables outside and inside the function. So first, let's create some variable inside a function. So let's say here we are creating a function with any name. Let's say show message. And then here we are creating a variable with the name message. And its value is, let's say, hello. And we are simply printing it. So we are printing the message here. And now we are calling the function show message. So it will definitely show just printing the hello. So here we created this variable and then printed it. But here outside this function, if we try to access that same variable message, so it will not be accessible. It will throw an error saying that this name is not defined. And why is that? Because this variable that was created, it was inside the function. And inside the function, we directly can't access it outside. And these kind of variables, these are called as local variable. So because this is local to function, it can be used inside the function only. So if we want some variable that can be accessed inside and outside both, then we create a global variable. So let's say this same variable, if we create it outside the function, so now we will be able to print it inside and outside as well. So if you see, now we will be able to use it. So any variable that is outside any function, that we call it as global variable, because it can be used anywhere. And now let's say if we want to change any global variable inside the function, we want to change its value to something else, then normally we won't be able to change it. So for example, let's say here if I say message equals to, let's say, new hello, and then if I run it, so what we will see is that first print message that is printing here, it says the new value, like this new hello. But when we print the message variable outside the function, it is again saying the original value. So the original value has not been changed. And here what is happening is that uh, when we are creating this variable again, so it is not using the same variable, it is creating another local variable with the same name, and that is why the global variable value is not changed. So if we want to use the global variable inside the function, we can use it if we want, but if we really want to change it, then we need to use the global keyword. So how do we mention is that we mention global and then the name of the variable. So now it will know that we are using the global variable inside the function. That is what we are referring. And this time, if we assign any new value, that same value will reflect outside the function as well and work it as a global value there. So this is how like about the scope of variable, whether it is local or global. And then next, let's see what is a short function that we can define using lambda. So to define any normal function, we need to use the diff, then the brackets, colon, multiple lines, everything. But let's say if we are creating some very simple function, then there is a shortcut in Python that is called as lambda function. So let's say if we are trying to uh, create a function square that just calculate the square of two numbers, then how we use lambda is that we specify lambda, then the input parameter, that is, let's say, x, then the return value, what value we want back, so that is, let's say, x into x here. So that's it. So this line that we have just defined, it is equivalent to what we would define like this. Let's say diff square, then x, and then let's say we would want return x into x. So either we define this function like this with all these details, or we use this shortcut. So if you use this shortcut, it will be the same thing as defining this. And if you see, I have put hash here, so this will not be actually used. So now I can call this square function as any normal square function. So if I say square, then let's say 9, and if I print the value, so I will be able to print square of 9. So that this is called as lambda function. So any simple thing we can define using lambda function. And here we used a single variable as input. Similarly, we can use multiple variables as input as well. So let's say if we want to create a function multiply, and that one again we want to define using lambda. This time let's say we are taking two variables x and y, and what we want to do is x multiplied by y. So this is how, by separating using comma, we can take multiple parameters or arguments as input as well. So this way, if we do call this multiply function, it will also work as the normal function now. So here if I pass 2 and 3, it will be able to print the multiplied value here. And next, let's understand what is a map function. So map function, it runs a function on every item in a list and gives back the results. So for example, if let's say we have a list numbers that has the values, let's say 1, 2, 3, 4, 5. And what we want to do is we have already defined a square function. If we want to call the square function on each of the item in this list and then get the new list, so for that purpose we use the map function. So how do we do is map, and then first we provide the name of the function that we want to call. So the function we want to call is square, and then the list that we want to call upon. So this is what we will provide, and whatever output we will be getting, so we will convert that output again to list so that we can use it as the list. And then let's say we call the output as squared, and then if I print squared here, so we will see that we are getting the squared value of each of the item in the list. So that is how it works. So using map function, we can call a function on every item in a list and get back the a new list with that function applied. And also here in this case, we provided the name of the function. But if we want to do something simple like square or something, then directly itself we can define the function within map using lambda as well. So in this same case, let's say if I copy paste the code here, and here instead of square, if I let's say lambda, then input variable, then output is x into x. That's it. So here, instead of defining that function separately, here itself within the line, we are defining a function and then using it. So if we do it, we will get the same thing. So overall, these may look like overwhelming and too much detailed thing. Once you will do some hands-on, then you will understand this better, and then you will be more familiar with these once you try it out couple of times. And the next inbuilt function that we will use is filter. So if we want to filter out some elements from the list based on some condition, then we use a filter function. So instead of map, let's say if I provide filter here, and this time here it was providing a multiplied value as output. But in case of filter, we have to use a function that only return a true or false. So here if I let's say x mod 2 equal to 0. So this is the like a conditional operator which will check if the number is dividing by 2 and remainder is 0, then it is true, otherwise it is false. So what it means is that it will pick up only the even numbers. For even numbers the condition will be true, for odd numbers the condition will be false. So if I run the same thing, so now it is printing only the even numbers, and this term it may be misleading. Let's say this is what we are saying, it is filtered, not squared anymore. It is just the name, but I wanted to correct it to remove the confusion. So this is how we can use filter to filter out data based on any condition. And then we have this last one that is called as reduce. And reduce, it works slightly different to map. So let me explain how it is working. I'm copying the code of this map here, and instead of map we will say reduce here. And reduce, it is not a like not available by default like map, so we need to import that. So that is available in a package. It is inside the this there is a package named func tools, and from there we need to import reduce, and then we will be able to use it. This importing, packaging, all this we will understand in more detail in later section. But here just think that we are importing this reduce function from this. There is a package that is there. So after we have imported it, now we will be able to use it. And this one reduce, it need a parameter that can take two parameters as input, a comma b, and then it will return the output of whatever operation we want to do. So if I say reduced here, and then we print reduced, let's see what we are getting, and then you will understand that. And here yes, this reduce, it will not return a list, that is why it is throwing an error. And that is the functionality of reduce as well. So here we are getting 120. So it may look strange, but how it is working is, it is doing like this: 1 into 2 2, 2 into 3 6, 6 into 4 24, 24 into 5 120. So it is taking one by one element, and then this is the operation it is applying. So that is how reduce works. It is like combining all the elements by doing some operation on it, and then providing a single output. That is how we can use reduce. So we can do, let's say, some multiply or some other operation using reduce. So it may also come very handy. So now, as we have understood all the core things about functions and using all these things, let's do a small exercise so that we can use a combination of these together, and then we will clear all our concepts in one program. So the task one here, it is that define a function called apply discount. So let's say diff apply discount that takes price and a discount with a default value of 10. So we have, let's say, price, and then we have discount. The discount has the default value of 10. And then it returns the new price after applying that discount. So what it will return is return, we will say price minus, we want to what we want to subtract is the discount is in percentage, so it will be price into discount divide by 100. So this will be the returned price after applying the discount. So here we have defined our custom function. Then the next step is store a list of prices, then use map with apply discount to get the discounted prices and using the default discount. So now first let's create a list called, let's say, prices. Here we will take the values, let's say 40, 60, 80 and 100. Now on all these prices we want to apply the apply discount function. So that one we will store into, let's say, discounted prices, and here we will use a map function. And in the map function, first we need to pass the function that we are going to apply, and then our list, the list that we will be passing here. And in this function, when it will be called, price will be passed one by one from here. Discount, as we are not passing, it will use this default value of 10. And then the output we want to take again as a new list. So first let's print these discounted prices to confirm that it is working as expected. So yes, it is running and it has returned the discounted prices by reducing the price by 10%. And then it is saying like use filter to keep only the discounted prices above 50. So now we want to apply a filter. So now let's say we want only high prices in a new list. There we want to apply filter, and in the filter we want to take a function, but we don't have a function to take anything greater than 50. So we will use the inline function. So this one, it takes, let's say, value x, and what it will return is x greater than 50. So if it is greater than 50, it will return true. Otherwise, it will return as false. And then we will give our uh, price list here, discounted prices. And the output that filter will return, we will convert it back to the list again. And then we will print only the high prices. So as you can see, it now contains the values which are greater than 50. So this one has been removed. These has been kept. And now the last one is reduced to add up the discounted prices that were kept and then printing the total. So now we want to use the reduce function to calculate total of all these. So now we will say like total equals to reduce. And this time we don't need to import again because previously we have already imported it. And first we want to define the reduce function. So if we want to do sum, it will take, let's say, x comma y, two inputs, and output it will return x plus y. So this is our lambda function. So we want to do sum of the consecutive items, and then we want to pass our list. So this way we will be able to get the total. So if I print the total now, we will get the sum of all these three items here. So that is how we used reduce. So in this exercise, we saw how we can define our own function, how we can use map, reduce, filter, and lambda functions in a combination. So you do it yourself couple of times, then only you will feel at home. Because if you are going through this for the first time, it may seem very confusing, and that is very normal. So just to do a recap, what we have done here, we understood how we can define a function using diff, how we can return any value, how we can pass and receive parameters with default values and their names, everything. We saw how we can pass variable number of arguments using star and star star. We saw how we can create local and global variables, and also we understood how we can create single line functions using lambda, and those how we can use them with map, filter, and reduce. So with this I would say like the core concepts of functions shall be clear, and once you have done this hands on, then we will be ready to move on to the next chapter. So now if you have already done hands on until here and if you are comfortable, then let's go ahead to the next chapter. So the next one, it will be about classes and inheritance. So first of all, let's understand like what is a class, why do we need it, and everything. So the concepts related to class and objects, those are called as OOP concepts, and it is very frequently called as OOPS concepts or fundamentals. So OOPS, it means like object oriented programming, where we create classes and objects. So class, what it is a blueprint for creating objects where we define attributes and methods. So it is like a, for example, let's say blueprint of a car. Let's say car, it will have a brand, it will have a model, it will be running, it can blow horn. So all those things we will define as a blueprint, but we have, let's say, not the actual car yet. So that blueprint, it is called a class. So in class we create a blueprint, and there we will define what all attributes and what all methods that we can use in for that class. And you will how to define it, we will understand it more when we will go to the hands on section. But think of class as a blueprint for creating any real object. And once we have a blueprint, from that blueprint, we create real objects. So let's say if we have a blueprint, then we can create one car of, let's say, Toyota brand and Corolla model. We can create another car for the, let's say, Honda brand and Civic model. So this is where we create the actual objects based on the blueprint of class, that we call it as object. So it is an instance of class that is actually created in memory, and it has its own data. In class, it was just a blueprint. It is not created in memory, and there is not having any data here yet. And then within a class and object, we define some variables that will store its values. Let's say if a car, it can have a brand, name of the brand, name of the model, like that. So these kind of variables, those are called as attributes of the object or class. And then uh, we will define functions also inside class. So whatever function we define, those are about, let's say, what that class can do with the objects. So whatever it can do, those we define as a function, as a normal function with some specific things we will understand. But whatever function we define inside a class, we call them as a method. So here the honk is a method. So basically, class is a blueprint, object is the real implementation of the blueprint. Objects and classes, we define attributes to store variables, and functions, which are called methods, to define what we can do inside the class. So this is the theory part. Now let's jump to the practical, do a hands-on, and then understand more about these concepts. So we are back in our notebook here. And here let's start by defining a class. So here we are saying like define an empty class called vehicle. So how do we define is, so we put the keyword class, and then whatever name we want to give to class, that we put it, and a colon. That's it. That's how we define a class. Currently, I'm not putting any body to the class. I'm putting pass. If you still remember pass, it is a placeholder. That means I will define the insides of class later on. But this is how we can simply define a class. So if I run it, so it is defined a class which has nothing. And from a class, we can create a object. Let's say my vehicle, if I want to create that as a object. And then we need to mention the name of the class that we want to create it from. And then we can even like try to print the object that is there. So here we see, like if you are printing my vehicle, it says it is a object of the class vehicle. So this is how we can create a object of any class. And if you see, we are calling this class as if it were a function, and we can actually provide arguments also here that we will understand as we go move on. But this is how simply we can create a object. And now as we have created a blank class, let's create some like class with some more body to it. So let me copy the same thing. And to create the body, like there is this very standard function that is used in every class. So this is double underscore init, and then again 2 times underscore, and then we start like this. And in this function we need to pass two like this is the default parameter we always pass whenever we create any function inside a class. And then if we need any other parameter, then we define that. And then there is this thing like self dot color equals to color. Let me write it, then I will explain it. So if we have defined it this way, and then if we want to create, let's say, a object here, then how we will do is, let's say vehicle, and this time we can pass a color here, let's say red color. And last time, like this vehicle was a blank object, but this time it has a color. So if we want to like get this color, we can say dot color. So if I run this, it will be able to print red. So what it means is that we have created an object of class vehicle, and there we have passed an value of the attribute as red. So internally how it works is, whenever we are creating any object, and whatever variables or parameters we are passing, those will that time always this is a like a inbuilt function with the name init that will be called automatically. And when this function is called automatically, it will pass that this red value to the variable that we have defined. And here normally we set the values to the object. Here self, what it means is that it is a like a reference to the same object, current object, whatever we are creating in the class. So here it means like here we are passing this red value as a color, and this color will be set as a value in as a color attribute of the class. That is how to read it. So normally we always use this init function. This is also called as initialization of class, and this is how we can pass any attribute value. And to access that any attribute, we use the object name dot the name of the attribute, and then we can get it back. That is how we can use it. And let's say here we only had the color, and we can even use like more than one attributes as well. Let's say apart from color, if we want age of the vehicle, then how we would do is like we will use, let's say, self dot age equals to age. So this way we will be able to store its age as well. Let's say our vehicle, it is 10 years old, so we will say 10. And then if we want to access the age, same way we will be able to access it. Let's say this one dot age. So this way we created the class now with two attributes. And here from this one class, so this is the blueprint, this is the actual vehicle. And if we have a blueprint, we can create multiple objects from that. So this is one object that we have created. Similarly, we can create another object as well. Let's say if I want to create my vehicle 2, that's color, let's say it's green. And then its age, let's say it is 5. So this way, like this is another object of that same vehicle class. So we can create as many objects that we want from the same class. And so far we have only created, I would say, attributes. Now let's see how we can create a function as well, or that we call it as method of the class. So we will copy the class again. And after outside this function, so I'm coming to the same line of function so that I can define another function. And here we are creating a function named honk. And that function, it does nothing, but let's say it will only print beep. So this is something we are, let's say, creating for testing. So now we have created a method of the class as well. And now if we are defining the same object here for that same vehicle class. So this time, apart from setting these values, additionally we will be able to call the function as well that is inside the class. So this way we can call the method of the class on an object. And this one, it failed because here I forgot to pass the self parameter. So this self, it has to be passed in each and every method that we are creating. That is how classes work. So this self, we could use it inside here also. Let's say here if I do another print and I want to access, let's say, color here, then what I would do is self dot color. This way it will be able to access the color and then use it. That is why passing this self is very important and mandatory as well. This time you can see when we called the function, it printed beep and then it printed color. And this same thing, let's say if we want to access other elements also, those also we can access. So here let's say if we want to add a describe method, and that prints a sentence using color and age something. So let's say we create another function here, div describe, that takes a self, it is mandatory. And then let's say it print, and here we will use the formatting and saying that a vehicle is created with, then we will specify the color. So color here, it will be accessed as self dot color, and it is, then we will say how many years old. So we will say self dot age, and then we will say years old. So this time, if we create the any object out of the same class, and then we call the describe function here, then it will be able to access these attributes that we had set up, and in the describe it will be able to access them and then do the operation that we have defined that. And we already know like how we can access any element of the object. Let's say we have created this vehicle 2, vehicle 2, and if we want to access its color, then this is how we can access it. But if we want to change it, that is also pretty simple. So if we say, let's say dot color equal to, let's say we want to change it to white, so that is how we can change it. Now if we want to print it again, we will get the updated value. So now the color has been changed to white. So this is how we can change the object of the change the value of any attribute of the class. So by now we have understood how we can create classes, how we can create objects, how we can like create attributes, methods, call the attributes and change the value of the attributes if required. So those all we have understood. And now we will go to the next level, which is called as inheritance. So we may have scenarios where we may want to create a subclass from a main class and then use the objects. For example, if we have created a class vehicle, it has some attributes and methods. Then we can create like another class car, which has all the properties of vehicle. And then car can also have some additional attributes and methods, and it can use both. So from vehicle, let's say we can create a car, we can create a truck. So that kind of hierarchy we can create, and that is called as inheritance. So let's go ahead and see how we can create a subclass from a main class. So as we already have a class vehicle, we will create a class car, and in the bracket we mention the like super class. We call it as parent or super class, and car it is the subclass. So that is how we specify it, and that is it. So that is how we define a subclass. That's easy, how easy it is. So I'm putting pass because currently I'm not defining anything specific within my car class. And let's try creating a object out of car. Let's say my car, if I say, then now I can create a object out of car class. And in the car also I can provide a color, I can provide its age, and then uh, I can, let's say, even call the method, let's say my car dot, let's say it has some function. What was its name? Yes, it had honk. So let's call this function honk and let's run it. So you can see like now we are able to create a object of class car and use it same way we were using vehicle. And that is the power of this inheritance, that all the properties, all the attributes and functions are now available in car without even defining it. And this is what is called as inheritance, that whatever was in vehicle, it has been inherited into car now. And this car it can have like its own attributes and methods as well. So let's say instead of creating it as a default everything, let's say now we want to add a new method here named drive, and that one it simply prints, let's say, driving. So let's say here we define it, let's say drive and self, and let's say we simply are printing driving. So now if we create an object of this class again, let's say my car, I will probably copy paste the same thing. And then now on this my car, what can I also call is the drive function that we have created. So whatever we have inherited from the parent class, we can use it, and whatever new method we have created extra, those also we can use in the subclass. So this car, it is also called as subclass also. And even we can override any function. If let's say a vehicle has a honk function, and in class we want to redefine some of the things, or let's say we want to use a something different there, so that is also possible. So how do we do is we simply define the same function with the same name here. Let's say self, and this time let's say in here we are printing, let's say car honk method. So now if we call the exact same thing, what will happen is instead of calling the honk function from the parent class, it is calling the honk function from this subclass. And it is like kind of we have overwritten the definition of the function defined in the parent class. That is why like defining the function with same name, this is called as overriding a method. This concept name, it is called as overriding a method. And then let's say if we have some requirement where even though we are overriding something, still we want to use the original functionality and some new functionality. So then how we can do is, so by default it has overridden everything. But we have this keyword super. So if we want to use any method from parent class, then we call it as like this. So if I say super dot honk, now what it will do is whenever we will call this honk function, it will come here. First, it will call the honk function from vehicle, from the super or parent class. Then it will continue the execution here. So this way, like using this super keyword, we can access the function attributes and methods of the parent class in the subclass. And this is how like we inherited the methods. Now let's say if we want to extend the attributes as well, let's say if we want to add one more attribute with the name doors. So how we can do that is, first let me copy paste this thing. So for that, if you remember, like we have a init function. So that can be used in any class by default. And we know that a vehicle, it already has a init function. So how we will use it? We will define it again. Let's say it will be self. Then the parent, it already had a color and age variable. And additionally, we want to use doors. So in this case, what we will do is, because init also is kind of a function, so that also we can call it using a super function. So if we call it this way, so first we can create an object of the a parent class like by passing the name and age like this. And once it is created, then here we just need to set up the doors of this object. So if I do like this, like self dot doors equals to doors. So now what we'll do is, like we are saying that car, it can have three attributes now. Two of the attributes we are defining them using the vehicle way. We are not assigning them again. And one additional one we are defining again. So first it will create an object like it was creating without having this function. After that it will add one more attribute with the name doors. So now if we are creating a car here, and then let's say if we are saying, let's say doors, if we are let's say passing 4, our car has 4 doors. And then let's say if we want to access all our attributes, so let's say if I want to print my car, it has a color, it has a age, and then it also has a uh, doors attribute as well. So all these it will be able to access. So this is how we can extend functions as well, override the functions, and we can extend attributes also in the subclass. So these are all the main concepts when we create a subclass. And then there can be different type of subclasses as well, depending on how we are creating subclasses. So let's understand those. So these are all the types which are there. So the one example we just now did, it is called a single inheritance. So we have one child class that inherits from one parent class. So this one to one, it is called a single. And let's say if we have a vehicle, we have a car, and then again we are creating another subclass, let's say electric car from this subclass, then it is called as multi-level. Now we have like multi-level is there. And then let's say from the parent class, if we are creating multiple child classes parallelly, so then it becomes a hierarchical inheritance. And this is like rare, not frequently used. But let's say if we have two different classes and we are creating a new class where we extend both of those classes, like we inherits both of those classes, then that is called as multiple. And then there exists a hybrid as well, where from one class we create two different classes, and then from those two, let's say if we are creating another class, so then that becomes in hybrid approach. So all these, I would say, these are just like different types we can extend the classes, but overall functionality wise it remains the same. Let's say whatever was in vehicle, it can be used in car. Car can have more. Whatever is in car, it can be used in electric car, and it can have more. Similarly, whatever vehicle has it, it can be used in all these three. And all these three, they can have their own additional attributes and methods. So that is how like this inheritance and this hierarchy works. Now let's check out these through some examples as well. So now we are back into our notebook. Let me copy this, and then we are going to build a subclass. First, we will build a multi-level inheritance. So how we will do is, let's say we have defined this class car from vehicle. Now we will define like another subclass from this car. So this time we will name it as electric car, and it will be a subclass of car class. And in this electric car, let's say apart from these three, additionally, we have a new attribute called, let's say, battery range. And now, because this is a subclass of car class, so in the super function, like now we can pass the doors as well, because doors are there in the car already. And then this new attribute, battery range, this is something we need to assign here. So now this electric car, it has one additional attribute and all the existing attributes of a car. And in terms of function, let's say here we are creating a new function named, let's say, charge. And then this function here, let's say we are saying it is charging. So now this is a new function on top of all the functions of car. So now if we want to create a object of this electric car, we will say my electric car. We can use any name by the way. And here we are saying like we are creating an object of this electric car. And now we are passing the battery range. Let's say this car can drive 300 kilometers on battery. So we have created now. And what it means now is that now on this my electric car object, we can use everything that is there in the electric car, and vehicle also. So, for example, so if we call the charge function here, definitely it will be able to call it and say charging. And let's say this honk function, let's assume it is not there in car. Then now let's say if we are calling honk function. So that also we will be able to use from the vehicle class, because from vehicle it came to car, from car it came to electric car. Similarly, drive function also we can use if we want to use on the electric car. So that is how it is multi-level: vehicle, car, and then electric car. And if we want to build a, let's say, a hierarchical inheritance where from one class we create two classes. So how do we define is, maybe let me copy the definition of vehicle so that it is easily visible wherever we are using it. So this is our vehicle class. And then from this vehicle class, we already, let's say, have created a car class. And then let's say from this vehicle class only, we want to create one more class named as truck. So this time we will name it as truck class, which is again from the vehicle class. And this time, let's say instead of doors, we want to take a parameter named, let's say, load capacity. So what is the load capacity of the truck? So if we want to do that, then that is the parameter we will use here. And now let's say it has its own driving function of the truck. And let's say here we are saying truck driving. So now if we create an object of truck, let's say my truck. So we can create it based on truck. So truck, it will have a color now. Let's say it is red color. Then age, which is let's say 10. Then it has a load capacity. So let's say it is 100. So this way, this object of truck will be created now. And now if we want to call the function, let's say my truck, then if I call the drive function, then the function from inside the truck will be called. And I can use the same honk function from the vehicle here as well. So now from here, from vehicle class, we have created two subclasses, car and truck. And this becomes the hierarchical inheritance. And then let's quickly create another one, which is let's say a multiple inheritance. So multiple inheritance, how does it work is, so here what we will define is, we will define a small new class called as electric. It will not be from vehicle car. Let's say it will be a new class altogether, electric. And then here let's say we just want to see it as an example. So simply I will create a function only. Let's say we are creating a function charge here, and we will pass self here, and then we are simply printing, let's say, charging. So this is one class, vehicle is another class. Now let's say if we are creating another class called as electric vehicle. So this electric vehicle, it can be a car, any vehicle which supports, which is a vehicle and which supports charging capacity. So both we can use. And how we will inherit from both? It is very simple, just by using a comma. That's all. So now this electric vehicle, it is inheriting from both vehicle and electric. And this time we will not implement anything, because we already know how to implement attributes, methods, everything. So simply we will see how we can create object of this electric vehicle. Let's say this is again my vehicle, and here it is taking two arguments. So one is color, another one is age, only two. And now we can see if we can use the methods of both vehicle and electric. So honk, it is able to use from a vehicle class. And if we use let's say the charge method, so then it will use it from the this electric class. So I think there is some typo. I need to use the same name. Yes, now it will be able to use the charge as well. So now one subclass inherited from two classes, it can use the attributes and methods from both classes. This becomes the multiple inheritance. So this is how we can implement different type of inheritance depending on our requirement. So now I know it may seem like too much information about classes, inheritance, everything. And then there is this only one concept additional that is there. Then this class thing will be over. This is also very important. It is called as access modifiers. So let's understand what exactly it means. So this is about setting the privacy of the attributes. So let's say the vehicle which had a brand or color. So we saw that attribute, we can use it outside the class as well, wherever we want to. So this kind of attributes, those are called as public, because those can be used inside the class and outside the class as well. So if you don't do anything, by default it is public. Then there is something called as protected. So this one, how it works is, if we put a underscore before the name of the attribute, then that is something, it shall be used within the same class or its subclass. It shall not be used outside the classes. That is the intention. It can still be used like technically, but the indication is that we shall not use. It is like a guideline that is followed. But if we want to make it more strict and don't even allowing it outside, then it is like if we put double underscore it, then it can be used only within the class. It directly cannot be accessed outside the class. So here, because we are controlling the access of these attributes, how this behaves, these are called as access modifiers. So let's understand these through the demo part. So for this, let me again copy our vehicle class. This time we will only play around attributes. So let me bring only that piece. So we have this one. So here we already saw that if I create a variable, my vehicle equals to, let's say, vehicle, we are passing some color, then let's say age. And then if I want to access, let's say, my vehicle dot color, we will be able to. So there is no underscore, that means both of these attributes are public. And if we put a single underscore here before the name of the attribute, now it becomes protected. So now if we are trying to access it, I think it shall allow access. Probably I think I missed this name. There is a typo, I think. Let me copy paste it. So let's try it one more time. So by default it is public. So now without any underscore it is able to access it. If I put underscore, then it is still able to access it if we confirm. So outside this class we are able to access it. But it is like a guideline or a standard that we follow, that we normally don't use it outside the class. As a best practice, we use it inside the class only, and we also use it in subclasses wherever we want. But if we want to make it more strict, then we make it private. Then what we do is like, we put a double underscore like that. Then if we try to access it using double underscore, it will not allow it. It will say that it is not accessible outside. Then if we want to access it inside, then what we need to do is, we can use it inside a function within this class. So let's say if I say get color, and then I pass the self uh, variable or parameter here. Then if I return here, and then I return, let's say, self dot underscore color, then it will be able to return it. So now instead of directly using it, if I call this function, so now because this function is public and this function is within the class, it has access to this color. So that is how like this color attribute, it can be used only within the class, not outside it. And that is what makes it private. And I would say that covers it all the concept. Only one piece is pending. That is this special function, which is str. And why we may need is, let me give you one example here. So let's say if we have this same class, and we have created this one, and we are trying to print the entire object, this one. So what will happen by default is, let's say it will say it is an object of class, it will not print anything actual. And that is where, if let's say I want to print that, whenever I use print on an object, I want it printed beautifully. Let's say this is a vehicle of, let's say, red color and 5 years old. Then what we can do is, similar to init, we have this str function. So in this function, whatever we return as a value, that is what will be printed automatically. So here we can say, let's say this is a, then we can say like self dot color, this color vehicle, which is, then let's say we are saying self dot age, like this many years old. So if we define this function, just by defining it, if I run this code again, now whenever we will use print, it will be able to print whatever we have defined in this str function. So this is something that can come really handy whenever we are trying to print or use any class object. So this can be very useful. And after learning all these concepts come our exercise. But this time I have typed so much code that I am tired. So only this time I will like paste this code instead of typing, just to explain like what we are doing, because we have done this thing already above. So let's say we are defining a shape class that has a init function and a color attribute. Then from the shape we are taking a rectangle class which has width and height, and then we are returning area as a function. Then we are creating another class from rectangle class, which is square. Square is type of rectangle where both height and width are same. So here we are simply calling the super initialization function by passing side and side into both height and width. And then if we create any object of rectangle class, we can call the area function to calculate it. And in the square class, like if we are calling the area function without even defining it, so just by passing a single side dimension, because we had used this super function, it will be able to call the area function automatically. So now here, although like it is calling this area function, so this is the function which is being called here, which is returning width into height. But width into height for square, it is, let's say, same side and side, which is 4. That is how, like using the same area function, we are able to calculate the area of both rectangle and square. So this is an example of multi-level inheritance. So that covers all the concepts related to classes and objects and all our OOPS concepts. So here we understood how we can define a class which is a blueprint, and using init function, we can put its attributes. We can use a self tag to access its own elements and setting them. We can inherit the class to a subclasses, and we can point back to the parent class using the super keyword. And inheritance, it can have different types, let's say single, multi-level, hierarchical, multiple, all those. And then if we want to print the objects beautifully, then we can use this str function. So this covers all the OOPS related concepts, and these are very important for understanding, and interviews also these are very like useful. Many questions can be asked about these OOPS concepts. So do your hands on, do your practical, and once you are comfortable until here, then we can go to the next chapter. So now in the next chapter, we are going to talk about modules and ready-made code that we can use in Python. So what is a module? So module, it is just another Python file whose code we can reuse in another file instead of just retyping the same code again and again. So we saw like how we can reuse the code using function, but there we used the code within the same file, within the same notebook. But if we are working on bigger projects, then everything cannot be put into a single file. So that is where we organize the things based on modules and multiple files so that we can import them and then use them. So that is how a module works. So let's create our own module first here. So what we are going to do is we will create a file with the name greetings.py. There we will create a function, say hello, that simply prints hello. With this example, we will start. So there are two ways to create that file. So first, let's create it simply manually. So I click this icon here, create file. Here we need to give the name. So name, let's say we are giving it as greetings.py. And then inside here, we need to define a function. Let's say we are defining say hello. And then inside this function, we are simply, let's say, printing hello. And then I will press Ctrl S to save this file. So now this file has been created and I will copy this piece of code here. So this is how like we can directly create the file, or there is another way as well. The file directly also we can create from within this notebook as well. So we have this command like percentage write file. These commands are called as magic commands in terms of Jupyter notebook. So let's say if I delete this file from there, and here if I type this, let's say write file, and then I say let's say greetings.py, and then I paste the code as it is, what we want to type here inside the file. So that's it. Now it will write the file for us with this name, and this is the content that it will write. So if I run this, I need to select this interpreter. And now once this is executed, it has written this file. So the same file has been created like we created manually as well. So however we create, it doesn't matter. Just I wanted to showcase this another way also. And once we have created this file, we can also say we have created our first module. So now if we want to use that module, then what we need to do is we need to simply call like import and then name of the module. So import greetings, and then whatever is inside the module, we will be able to use it. So let's say greetings is our module, the name of the file, and then we have this function say hello. So that function we will be able to call here. So this is how like we just built our first module, simple one, and then imported the module and called a function from inside the module. And in this case, like it will import all the methods which are available, those will be imported here. But if we want to specifically import only some function, there are let's say a lot of them, then also there is another way. We can say from greetings, we can say like import and say hello. This way we can import a single function also. So this way also it will do the same thing. This time instead of importing entire module, we imported only one function from the module. And while importing, we can use a custom name as well. Let's say we can say h. So now if we import this way, we will be able to use that custom name as well. So while importing, we can say like as with this name we are importing. So these are all the different options which are there. All works almost similar way. And in this case, we imported a module that we had already created. Similarly, within Python also, there are like different modules which are available. So how we can use them? For example, there is a module named math. So math is a module which is available. We don't need to include any file for this. It is ready to be used within Python itself. So, and within this module, we have multiple function. So one of them, let's say it is square root. So if we want to calculate the square root of 9, then we can use it. So simply if I want to print it, then we will be able to calculate and print square root of this. And there is a small functionality of this Jupyter notebook that in the last line, if we don't use print, then whatever the last line is providing, that is also printed automatically. So whenever we are using it in the last line, like if we put some variable or something, or what value it is returning, it is printed automatically also. So we don't need to use that print statement explicitly as well. And this is how we can import any module that is readily available within Python. And then because Python, it has evolved so much, like people across the entire world, they are building their own module and making them available. So we can use other people's modules also. So when we installed Python, there are some like fixed number of modules with like that list is also big, but those are already installed. Whatever module we need to install like outside that ready to be used, then we need to first install those modules into our system so that their files come into our virtual environment, and then we will be able to import those modules and then use them. So let's take one example and then we will understand this. So there is a module in Python with the name python-.env. This is used to store our API keys, password, username, all those things securely. So this is the module we will install. And to install any module, we have a tool that comes up with Python. That tool is called as pip. So how we can use pip or pip to install this module is, so there are two ways, like within Jupyter, also we can call this command, let's say percentage pip install, and then the name of the module, let's say python dash dot env. So if I run this, this will install this Python module into our virtual environment. So it has collected the info, it has installed, installation is successful. And this is where the role of virtual environment becomes more important. Now, when we install this module, we are using the current VENV, virtual environment, where this folder is created. And the files related to this module that was installed, that goes into this library folder. So here somewhere we will find that python.env related folder and more files. So this is where this module is actually installed. And if we don't use any virtual environment, then this module will be installed in the main Python that we had installed in our user location or in the C directory. But in future, let's say in other project, we don't need it, or we need a different version of this library due to compatibility or something. That is where we get this problem. And that is why Python comes up with this virtual environment concept. So whatever modules are required for this project, if we are using this virtual environment, those will be installed here only, and there will be no impact on any other project. So that is how it works. And this is one way to install it. And let's say due to some reason, if we are not using Jupyter notebooks, then also like directly as well, we can install modules. For that, what we need to do is we need to go to terminal and new terminal. So it will open a terminal. It is like a command line that is there for us. And here we can see like automatically it has opened this .venv. So whenever we open terminal, we have to make sure that this .venv is coming up. It means that currently this virtual environment is selected. If you don't see this, then it means that whatever you will install here, it will go to the main Python, not into this virtual environment. And here also we can use the same command. This time we don't need to use percentage because this is a terminal. Directly we can run it as a command. So if I run the same command again, we will say that requirement already satisfied. So because there we already installed, it is showing that way. Otherwise it would install it first. So this is another way to install it. And this is also like a more familiar and more famous way to install it, that in terminal we can go and install directly. And this way we can install any module one by one module at a time. But when we work on bigger projects, then we need to install like multiple modules in one go. And that is where there is this concepts of requirements file. So in every project that we work on, like wherever we work on Python, we create this file like requirements.txt. This is a very standard name used for specifying the libraries that we need for our project. So we always create this requirements.txt in the main folder wherever we have this virtual environment folder. And there we provide the list of libraries that we need. So let's say this python-env is one. And let's say we need another library requests. This one we will use later on. So whatever libraries we need, we simply need to provide here, let's say like this dot env. And then in the next line, we can provide another library. In this case, it was requests. And by default, it will install the latest version of the library. And if we want to specify any specific version of the library, that also we can specify here. For now, we will install the latest one. So I have saved this file. I will close this file now. So however we used, let's say pip install. Similarly, what we can do is, let's say we can run the same thing like pip install. This time, instead of mentioning the name of the library directly, we specify -r and then we specify the name of the file. So .txt. So if I run this command, then it will install all the libraries. It could not find the file. Looks like there is some typo in the name. So here the name looks like fine. Uh, but the thing is that by default, it will look for this file in the current directory. So as our notebook is inside this practice notebook, but file is outside. So this file is not inside the same folder. That is why it is throwing this error. So if we say, let's say // then it will go to the previous directory, one directory outside, and there it will look for the file. So now it will be running fine. So now it is installing the requests library and whatever other things are required for requests, everything it has installed. And this same command, like you may guess already, we can run from terminal as well. So here also we can use the same command without the percentage. And this time it is failing because this file, it is available in the same directory. So I need to remove this. And then I need to run this. So it is saying it is already satisfied. So this is the current directory Python course. And in the Python course only, this requirements file is there. And although we can use any name of this file, requirements.txt, but this is the very standard name that is used by everybody. Even when we create a new virtual environment, it will look for this file and try to install the libraries mentioned automatically. So this is the standard way to install any library or any module for the project that we are working on. Now moving on, I will close this terminal. And then we have already installed packages. Now we will try to use one of the module that we just installed, the .env module. So here what we will do is, how does this module work? Let's say we are working on some requirement where we need to store username, password, or that kind of thing. So then what we do is, there is a very standard module that is used. So we need to create this file .env. This is the name that is used as a standard everywhere. And here we can specify anything. Let's say username equals to Narender. And then let's say password equals to my password. So these are the names I'm giving. And now I will press Ctrl S to save this file. So now from this file, although we can read like as a file and then do this, but this is a very standard practice that we create this file with .env, and this file is never pushed to GitHub or any repository because this is a sensitive information that we store here. And then we can read these keys automatically without writing any code. So for that purpose, we use that module. So we have created that module already. Now what we need to do is we need to simply import it. So we have this module .env. From that we need to import this, import or use this method load.env. So let's go ahead and import that. So from .env import load.env. This is a function we are importing. And we also need to import OS, operating system. This one we will understand more in the next chapter or in the upcoming chapter. For now, this is like operating system, which can help us to read system variables. So now what we need to do is first we need to call this function load.env. So now when we run this, what it will do is this function, now it has run. So it has looked for this file .env automatically. And inside this file, whatever key value things are defined like this equal to, so it has set up these as a system variable names. So these are like system variable are standard variable like path, and there are other variables also which are available in our operating system. And now if we want to get their value, so simply we can get like this operating system dot get env, and then we need to pass the name of the variable that we are looking for. So here we are trying to read username. So now when we will run it, it is printing the username as Naren. And although we had stored like username as Narender, I think like this username keyword is a very standard keyword. So it has not replaced it probably. Let's try to use password first. Yes, password, it is printing as my password. So let's say username, instead of using this standard because it is reserved or something, so it is not able to replace that. So if I use, let's say, my username as a key, then it shall work. So yes, now it is working properly. Default username, that is like the username of my Windows user. That is what it is providing as a default. So this is how like we installed a module, and then using that module, we can store any sensitive information into a separate file and then read it from there and then use it into our code. So that completes our module section. So here we understood how we can create our own module, how we can import it, how we can use any ready to use module like math, how we can install some module as a single module or putting it in a file and installing multiple ones. And we also understood the use of the environment module, how we can store environment variables into this .env file and then use them however we want. So I hope this is clear. This was a quick one. And now let's move on to the next chapter. So in the next chapter, we are going to talk about error handling and debugging. So first, let's understand what exactly is an error. So when something goes wrong when a program is running, then Python, it will stop and it will show the error message instead of continuing. So it will stop executing the program. It will not go forward by default. So whenever something unexpected happens that the program cannot continue, that is what we call it as error. So for example, if we are saying a equal to 10 divided by 0, we are trying to assign it like this. And if I run this piece, it is throwing an error. It is saying like 0 division error is there. This is the error message, that division by 0. So this is a, by default, it is a invalid mathematical operation. So it will not be able to continue with the execution, or it will not be able to assign this value. So this is an example of error, and there are various type of errors that can happen that we will see when we go further. So there is a way how we can play around or handle these errors in different ways. So to handle these errors, Python, it comes up with this try and except blocks. So whatever code we are running, let's say this division by error, so we put that in the try block. And now within the try block, we specify the code which can execute successfully or it can throw an error. So let's say here, if we are doing the same operation, and then if we specify, let's say except. So except is the block that will be called whenever this error will happen. And then in the except block, we specify the type of error that we want to handle. So this is the type of error we are getting here. I will copy this name from here. It is also a class within Python. Like whenever we will divide something by 0, it will throw an error of this class. And then we say like is E, we give it an alias, and then we can print any our own error message. Let's say divide by 0 is not allowed. So if I run it, now like it is this line, it is still throwing the error, but that error now we are able to catch here. So it will now going to this except block, and here we can still do whatever we want. So how it will make any difference is that, let's say there is further any code that is there after this line. Let's say print hello. And now we can see that overall program execution is successful. Whatever code is there after this try except block, so even though error happened, it is able to continue the execution. And here we can do whatever we want. If we want to stop, we can stop it. If we simply want to show an error message to user, that also we can do it. But if we don't use this try except, then what happens is that if we have some further code or what more operations we want to do, it will not continue. It will stop the execution there, and it will say that the error is there, and it will say at what line the error is happening. So that is how like we can uh, handle any type of error that we want. And this except, its full form is exception. So the technical term for errors, we also use it as exception also. So here we are trying this code, and then like in the exception we are handling it, and then are doing something. So that is how we call it technically. And if this code, let's say it is not throwing any error, then what will happen is, like it will not go to this except block, and simply it will execute this code and go to the next section whatever is there after the except block. So that is how, like in simple terms, we handle error message. And whenever we are handling error message, so here we typed our own custom message, and whenever we are taking this reading this exception, then it comes up with its own message as well. So here if we say like then we can say error equals to, and then if we specify like e, or this e that we are reading here, so this will contain some message from that error as well, that also we can use for whatever we want. So now whenever it will throw this error, so that error that is inside this e object, like which is a object of this class, it will print that error here. So that also we can use it for a logging that we will see further, or for anything that we want to do, we can read it. And this is one type of error that we saw here, and there are different types of errors that are there. So one of them is value error. And when do we get it? Let's say we have a text something, let's say a is a text, and then let's say if we want to uh, convert it to an integer. So if I say b equal to, if we want to convert this to integer, so because this is a text, it cannot convert it. So it will throw this value error. So this is the class, this is the message that is there. And this also, if we want to handle it, the same thing we need to do. So it will start with the try block, then whatever code that is there, and after that we have this except block. So except, this is value error, we can say is e, and this time let's say I simply want to print e, whatever value we are getting. So now the program has not failed, and it has printed the error message that is available in this exception. So this value error is another type of error that can happen. Similarly, we have another error, like that is, we call it as key error. So this is something previously also we were talking about it. So let's say there is a dictionary where we are storing ages of different people. So let's say we have stored the age of two people. So here key is, let's say, the name of the person, and then value is age. This is one key value pair. And let's say we have another one for Alex, and the value here, it is his age. So in this dictionary, if we are trying to look for, let's say, uh, AZ equals to, from this age dictionary, if we try to read something that is not there, let's say Jamie here, so then it will throw an key error. It will say key error, and that this key is not there. So that is the meaning of this. And that is what I was talking about. So if we are looking for something as a key that is not there, so that is why this square brackets normally we avoid it. But first we handle it, let's say, and that is the thing with except also. Here, value error, we might want to do something different. And for one try block, we may have multiple except blocks as well. So let's say in this except, we can also specify like this, let's say key error. And then this is also, let's say, is E if we want. And then we can want to print E here. Here I'm simply printing, but in real projects, we may want to do different things here. And in this case, the error message, it doesn't look good. It is only saying Gemini, the key which does not exist. So we may want to print our own message saying like key is not found equals to, and then we can specify this E. So that is also another thing that we can do, which can be helpful in deciding like what actually is happening. So like this. So now we will get a proper error message. And this is like one of the error that we did. Similarly, there is another error that can happen, which is called as index error. This also briefly we talked about. So let's say we have like numbers equals to, we have a list, let's say 1, 2, 3. And then these numbers also we can access them using index number. So let's say we are saying num equals to, we are saying let's say numbers and then 0. So 0 index, it is existing, and I'm commenting this in above line because we are not using it for now. So it will execute successful. If I want to print the num here, I will be able to print it because there is no error here. But if we are, let's say, going to the index 3, so 0, 1, 2, these index exist, 3 does not exist. So in this case, it will throw an index error. So if we want to handle this, again, we can do like this. Let's say index error. And then we can say like index not found or something, whatever message that we want to use. So it is message is also in this case, it is sensible saying list index out of range. So this is another type of error that can happen. And handling more than one kind of exception, this one we already see how we can handle it. But until here, you might think like in this cases, it is throwing an exception, then I'm handling, and how would I know like this exception can happen or not? So for that reason, there is a like generic exception that we can handle. So instead of any error, if we specify exception, so this exception, it is like a generic thing that can handle any error that can happen here. So for example, here, let's say in this case, if I did not have that, now I don't have that index error, but we have exception error. So if I run this code, it will still be able to find that error has happened, and then list is out of range, that is the error message. So this exception, it can actually handle anything that is that can happen. If I remove everything else, and this time let's say here I will be getting the key error, so it is able to handle that as well. So this exception, it is a master class of all the errors, so it can handle everything. So, and how it works is we always either keep only one or we keep it at the end only, so that if that specific error except block is there, it will go there. If that is not there, then it will go to the except block and do that. And you might also think that if this can handle anything, then why do we need others? So in real projects, we might want to do different things depending on the error as well. So let's say if we are getting any value error, we might want to print that the value is invalid, please enter a valid value, something like that. And if we are getting a key error, so maybe we may want to stop the execution or something. In some cases, we want to stop the database connection. So different things we might want to do. That is why we have these different classes. So if we want to handle something specific, we mention the type of the error that we want to handle. If we want to handle everything using generic, Then we use this exception block. And then apart from these, there is something called as finally as well. So let's say we have a requirement that, uh, for example, if we are opening a database connection or something like that, or opening a file or doing something, what we want is whether the error happens or not, finally we want to close that or we want to do something different. So we want to do that whatever happens, like error happens or doesn't happen. Then for those kind of scenarios, we have a block called finally. And to use that, simply we need to type finally. That's it. Here we can do whatever we want to do. So here simply if I put like inside finally block, and if I run the program, so if the error is happening, then also the finally block will be executed. And if the error is not happening, let's say here is a valid index that is there, then also the finally block will be executed. So in this case also it is executed. So if we want to execute something in both cases, then we use this finally block. And next, let's say if we want to raise some exception on our own, which is not existing or by default it will not be raised, then how we can do it? So let's say if we are creating a function named, let's say, set age here, which takes a variable age. And here what we want to do is, if let's say age it is greater than equal to 0, then we want to simply, let's say, print age. So let's say we want to say, let's say age equals to, and then value of age. And if it is not greater than equal to 0, so else, then what we want to do is we want to raise an error, because age it cannot be negative. But when we work with Python, so age is a integer, so technically a integer number can be negative. And that is where here we may want to raise our own error, even though Python is not raising it, because age cannot be negative. So how do we do is we use this raise. Whenever we want to raise exception ourselves, then we use this. Then here we mention what kind of error we want to raise. In this case, it is a value error. And if we are not sure what error type of error to raise, we can simply put exception, and a generic error also we can raise. And here we can provide our own custom message like age cannot be negative. So what this function will do is, if it gets any age which is positive, it will print it. If it is negative, it will raise an error. So now let's say if I call this function set age, and if I, let's say, call it with value 4, it will be able to print it. And if I call this same function with, let's say, -4, then it will raise that error, value error, saying that age cannot be negative. So this is how uh, we can raise our own exception. And this also we can handle it the same way we were handling other things. So this also we can put in a try block, and in the except block, like, we can handle the value error as e, and then do anything that we want to do. So here also, let's say we can print that message that simply if we print E, it will also do the job. It is saying age cannot be negative, and we have handled that exception. We may want to do whatever we want to do here. So this is how we can raise our own exception and then handle that as well. And then these are all the core concepts that I wanted to explain. And now let's try to put these together and then complete this module. So here what we need to do as a task is ask the user with for their age from input method. If it's a valid whole number, then print it back. If not, then catch the error and then print an error message instead. So first let's take age as input. So for that we have this input method, and here we can simply say like enter your age. And then what we will do is we will say, let's say, my age equals to, by default it will return as a text value, the input function. So we need to convert it to an integer. So now we will get an integer here if it is valid. And this is what we will put in a try block, so that we can handle an exception if user is not entering a valid integer. And now what we will do is, here let's say if it is valid, then we will simply print it. So print, then we can say in message that you are whatever age has been entered, years old. And then in the except block, what we will do is, here if we want to handle value error here, if it is an invalid value, then we will print an error message saying that uh, entered is invalid. So this is the message that will be printed. So if we want to run it, it is asking for our age. If I mention, let's say 21, enter, it is printing the correct message. And if I run it again, this time if I provide any text here, then it will print the error message instead of the age. So this is a simple exercise that we did. So this is all about this error handling. So here we understood that how we can handle error using try except, different types of errors we understood, like zero division, value, key error, index error, etc. And we understood like how we can use multiple except blocks and a master exception class. And then finally block we understood where it will run irrespective of the error is happening or not. And then we understood how we can raise our own custom message as well as an error. So all these things we understood. I hope these are clear. And once you are comfortable and understood these concepts, then let's move on to the next chapter. So this next chapter, it is all about logging. So what logging is that? Like it is a like alternative of using print statements like for development and production systems. So print, although we are very familiar with it, we want to use it everywhere. But print while working on development, it is fine because we can see the print messages and everything. But in production systems, we never use print messages. And why is that? Because one is that print message, those are printed only when the application is running, and the output, it is not stored anywhere. So in future, if I want to, let's say, look at the code that ran yesterday, what all things happened, I can't see it. That is one thing. Second, print is just a print. So everything will be printed. But in real projects, we may want to set some level that if let's say warning or error is happening, then do this, then only print the messages. Or we may want to also customize the printing or the messages that we want, let's say putting the time along with it so that we can know when it is happening. So all those customization we may want to do it. We may want to store those messages in a file so that we can look at the file whenever we want to. So to solve all these use cases, there is a module called logging. And every developer who is working on a real project, we always use logging and we don't use print statements. During development, we may want to do it to quickly print something, but in real production grade application, putting print is not a good practice. So print, as we already know, how we simply use it, like print, and whatever we want to print, simply we can do that. Now let's understand logging and how we can use it. So logging, it is a module or it is a library that we can use. So if we don't need to install it, it is readily available. So its name, it is logging. And then whenever we want to, let's say, log any message similar to print, then we have different functions that we have different levels what we can use. For now, let me use info. I will explain these levels as well. And let's say this is an info. And then there are other functions also available. Let's say warning. If we want to warn something, then let's say we can say this is a warning. And here we can see that info message is not shown here. Warning is shown. And there is a reason, because these are different levels, and then we can set the level, what level of messages we want to show or include in the logging. So first let's understand those levels that are there. So in total, there are 5 levels. So first one is debug. Debug is used to include some very small detail like printing the value of some variable and printing like if condition is true or not. Basically, printing each and everything in the code that can help us looking at the log and debugging later on what went wrong. So that level is called as debug. Then info is a normal level. It is called as a normal information that let's say this process is complete. Now this process is starting. Those kind of updates if we want to provide. Then we can use this info level. And warning is the name it suggests like it is something to be careful, but it is not a failure. And then error, it is that we already discussed. It is a failure that has happened. And apart from error, we have more critical level also. That is like the program, it can't even continue. Error, we can still handle using except and then print something and then move on. Critical is something that we have to stop the program and we can't even continue. So for these cases, we use critical. So these are the different levels, and how do we use them? Simply like the same way, like uh, info and login info and warning we already tried to use here. And then uh, let's say we have this info dot logging dot debug as well. Same way, logging dot debug. And then let's say this is a debug message. And then similarly, we have logging dot error. And let's say this is an error message. And then we have like critical. So we can say like this is very critical. So if I run it now, so by default, you will notice that a warning, error, and critical, these messages are coming, and debug and info, these two messages are not coming. So the reason for that is there is a default level that is set up which we can control. So now let's see how we can control that level, how many messages or what level of logging information shall be used. So that one, how do we set is we have this like logging dot basic config. This is a function that we call, and then here we specify like level equals to then logging dot we can specify any level that we want. Let's say if we want info level, then we specify like this. And then we have another parameter force, which we need to set it up as true. It is like we are forcing this information. It has to be this way. Otherwise, it may not force and use the default or something. So now if I run this same program, we can see that now info is also coming because the label has been set to info. And if we want the debug information, so then we will see that everything will come up. So whatever level we have set up, the values greater than that level will be printed or that will be stored in the logs. And that is how we can control it. So when we create our program, we can put all kind of messages like some with debug, info, warning, error, and critical. And then this level we can set it up only once at the start, or we can control it through configuration as well. So by default in production we will run it with let's say warning or info, so that only the important messages are coming. If something goes wrong, then we can change the level to debug. Then whatever debug messages we had kept in detail, those also will be coming, and then we will be able to use those. So that is how we can change the level however we want, and then we can use it accordingly. And next, let's see how we can customize our messages that are coming via logging. So apart from level and force, we have other parameters that also we can specify. So one of them is format. So this format, like it has to be specified in some very specific way. And how do we do that? So it supports like different kind of information. So one of them is time. So how do we provide time here is it is provided using ASC time, and then we need to like provide it like this percentage and then s. So this is a standard way. We have to specify it this way. And after that, let's say if we want the level of the log. So level, it means like whether it is a debug info, what kind of message it is. So for that we have this word like level name. So using this, we will be able to like provide a name of the level now, and then we can provide the original message that is being provided. So message we can provide like this. So this message is nothing but whatever a string we are providing while we are using the logging module. So now if we run it, we can see we are getting the time automatically. We are getting the level and then the message. So this is more structured way. And in when we standardize this, like we put a separator also. So although we can put any separator, but using pipe is a normal way, everybody prefer it. This way it looks more clean and more manageable. So this is how whenever we are using logging, we can customize our message as well however we want to do it. We can even provide name of the file, name of the function, while configuring it, so that every time it will do it automatically. So that way we can customize our message however we want to. And now in the next piece, so far like we have been just printing these messages and we can see here. But the real value of a logging module comes when we store these messages into a file so that anybody can go there and then check it out. And how do we do that? It is also very simple. So while creating this configuration, we have another like a, a, a parameter that we need to provide, file name. So here we can use any name, but let's say giving some name dot log is the standard practice that is followed. So if we specify this, and now if I run this, I think I forgot the comma here. Let me run it again. And now it is complete. So this time you can see it did not print any message, but the message it has gone to this file. And if I open my folder here, this is the file that is created automatically. And this is how the messages has been provided into this file directly. And this is how like things work in actual production grade applications. So that like there is nobody to see the messages when it is program is running, right? So whenever execution is complete, we get generated these kind of logs, and then these logs we can analyze whenever we want to and then use them. So these are all the core concepts related to logging. And I hope it make more sense now to use logging instead of printing, because you can see the benefits, right? Like we can customize the message, we can store it in a file, we have these different levels. So all these benefits we get. So now let's do a quick exercise so that we combine our learnings and then do it. So the task here is that we configure the logging with force equal to true to write it into a file checkout.log, and then we go through a list which is prices, and we log it like when we start that we are starting the process, and an info for each of the price that we have added. And whenever there is something wrong with the price or price is not valid, then we shall print some error message, or we can print it as warning as well instead of error. So to start with, what we will do is I will copy the above one only so that we can reuse some of the things. And this level we will leave is at default. This time, let's say we can name it to some different file name. Let's say checkout.log, so that like it create another file this time. And then we create a list, let's say with these values. Let me copy this same one. So we can say prices equals to this. These are all the prices that we have. Then we can say like logging.info, and we can say process has been started. And then we can say like for price in prices, we want to go it over a loop. And now let's say what we want to do is whatever prices are valid, we want to add them. So I'm creating a variable total equals to 0. So by default, because it has all these different type of values, we will need to try to convert it to a number. So here we can say like amount equals to, and this time like for conversion we will use float because it is having decimal points in it. Then we want to convert the price type here, and then we can say like total equals to uh, total plus amount. And we can definitely use like total plus equal to amount if you have guessed already. Then what we need to do is we need to print a message here. So let's say we want is like logging dot, this is also let's say a info. So we are saying is that we can say processed the price equals to, and then the value of the amount, that this one has been processed. And as we know, like while it is converting the values which are not valid, it will definitely throw a error. So how we can handle is using our try try except blocks. So try, then I need to shift these to right for the indentation purpose, and then here comes our except piece. So except in this case we know it will be a value error, or we can use the generic error as well. So this is how we are handling. And in this case what we are printing is that we can say like cannot process the, then the value of the amount we will not get because it is not yet converted. We will have to put price here, and then we can say because it is not valid number, and we can say like error message equal to, then we can say e whatever message that we are getting there. And this time I put print here, that is how familiar we become. But we want to put this as warning. If we want we can use warning, or we may want to use it as error as well, whatever we want to do. Normally if we are continuing with the execution, that means it is we are not stopping it, and it could be a warning, but it can be anything that we want. And although we have all these different levels, in real projects, like normally we use info, warning, and error, only these three. Critical and others normally we don't use, although those are available. So now if I run this program, so we will say nothing is printed here because the log it went to this file. So let's check out our log. Here we can say like process has started, it has processed this, then it processed this. Then when it got a invalid value, this one, we got a warning that it cannot process. Likewise, these two are processed. Here we got a warning, this also, it was processed. So that way we get a very detailed logging along with time, along with these different messages, so that we can filter out errors, search for them, or whatever we want to do. So that is how this logging module it makes it very strong, like in terms of debugging and finding out what could be wrong. So in this module what we understood is like how we can use logging instead of printing, what are the different levels that are there, how we can customize it to decide the log level, putting it in a file, and the format as well. All those things we understood. So I hope this is clear. This was a quick but very powerful one. Once you feel comfortable, let's move on to the next module or next chapter. So now in this next chapter, we are going to talk about some standard libraries which are available that you shall be aware, and how we can handle files while working in Python. So first let's start with a standard library, OS, operating system. So if you remember, we already used it when we were reading the environment variable. So apart from just environment variable, it has some different things as well. So let's say if we want to get the current working directory, so then how we can use it? We can get it using OS dot. We have this function get CWD, current working directory. So if we do that, we will get the current directory that we are working on. So this is the directory where our notebook is there. and we got this directory in by using this function here. So this can come handy if we are playing around folders and files and all that. And then the next function that is there is listing the directory. So let's say os dot if we have this list dir, and then let's say if we want to list current directory content, then we can use dot. So dot, what it means is, in the current directory, whatever files and folders those are there, we will get them as a list. And if instead of this dot, if we specify the exact path of what folder we want to list the subfolders and files, then that also we can use here. So that is the purpose of this list directory. And then the next system function that is available is exit function. So sometimes we may come across the scenarios where when we want to stop the execution of the program ourselves. It could be, let's say, part of the except block, we want to stop the execution, or like there could be some scenario based on some if else condition or whatever we want to do, where we would want to stop the program. Then we have this special function like sys.exit. So let's say if we are printing simply some numbers, let's say print 1, like this, we are printing different numbers here. And due to some reason, after 3, if we want to stop the process, then what we will do is we will use this sys.exit function. So we will need to first import it, and then we can use it. So now if I run this program, it will continue until 3, and then here we can see that it has not like continuing with the execution, and it has exited the program based on our command. And if we want to provide any custom message like this is why we are exiting, then also like that message will come up like whenever it is exiting. So although we can use, let's say, even raise exception also wherever we want, but that will say like something went wrong and there's some error happened. Exit means we are intentionally exiting. So both are doing similar thing, but this one it means like somewhere we called exit ourselves. So this could be like another thing that might be useful. Then the next thing is, let's say, about using today's date or time. So some there could be scenarios where definitely we would want to get current date, current time, and etc. So for that we have this module date time that is ready to use. And if we want current date, then what we do is like date time dot date, and then if we want today's date, then this is how we can get it. So we get this object of today's date that we can use. And if we want time, then we have like a date time, and then dot now. So this way we get an object of current time that is there. And if we don't want this object, but if we want it as a simple string, then also we can use that. Let's say if I try to print it, or let's say if I assign it to some variable, let's say time equals to, then if I want it as a string, then also we can get it. So if I put this str, and then if I print it, let's say time here, then we will get it only the time part of it. So uh, year, month, date, hour, minute, second, and even millisecond and all. So we get the very detailed time and date this way. And these were some useful like generic functions and libraries which were available. Now let's see how we can play around with files. So now what we want to do is we want to create a file with the name notes.txt and then write something to it. So how do we do is we have like with, this is how we do it with open. Open is a function, and here we can specify the name of the file that we want to work on. So here it is, let's say note.txt, and then we also need to specify in what mode we are opening. By default it will be able to read the file. If we want to write something, then we specify w. W means write, and then we say is file. So this file is a tag or a variable that we will get to play around this file. Then if we want to write something, we will say file dot write is the function that we will call. So we can say hello, and that's it. That's how we can create a file and then write to it. So here if I say simply if I want to print some message that we have uh, written it. So now if I run this, it has created the file automatically. So this notes.txt, and the whatever we had written there, it has written there. And if we want to write more thing, let's say if I want to specify current time, if I want to write, so we have that same thing. Let's say uh, date time dot now, and then let's say we may want to write something more. Let's say file dot write. We can write another thing if we want to. Let's say this is another line, something like that. And then there is one more thing we take care while writing things. So by default, it will not know that it need to go to next line. So that thing also we need to specify. By default, it will write in the same line. And how do we specify that it has to enter a new line? Simply, it is the escape character it is called. So backslash n, it means next line. Backslash t, it means a tab. So that is how it works. And above one also, if we want to enter a new line, so we will have to provide this thing into a kind of variable so that it will call it separately. And after that, we will provide it as like backslash n. So this way it will consider this as a next line. So if I run it, and now if we go back to our file, we will say now it has written 2 lines, and then it has like entered a next line as well. So that is how like we can enter multiple lines into a file. And then if we want to read something, then that is also like simple. So uh, this time we will open it in the R mode. R means we are reading it. And to read everything in the file, we have this function. Let's say if I want the everything to be read and then put it in the content as a variable, then we will say file dot read. That is the function that is there. And if after that, if I want to print the content, then I will be able to print it, or what we can do it whatever we want to do. So I wanted to give it a name content, and that's it. Now it will read that same file and print what content is there in this file. And if we want to read the content of the file line by line, then also we have a function. So this is our file. Let's add something like randomly to get multiple lines here. I'm saving it. And now what we will want to do is reading it one line at a time. So for that, like instead of read, the function that is there is read lines. So this will read it lines and provide it a kind of a dictionary. Sorry, no, as a list. So now because it is a list, so we can use a for loop to go over this. So for line in lines, then we can print one line at a time. So we can say like line equals to whatever we want to do. So whatever custom operation if we want to do based on line, so this way we can access one line at a time from the file, and we can read the line by line. So this is how we can play around files. We can write something, read line by line and everything. Next, let's understand something special, that is JSON tag. JSON. So JSON, it is called as JavaScript Object Notation. It is a very standard format of writing key value pair into files. And it started with JavaScript. That is why its name fell into JSON. But it is supported by every programming language that is there. and it will look similar to dictionary, and that is why like understanding this is very important. So for this one, first we will create a dictionary, let's say person, and this is how we create it. So we have a key name, its value is let's say Narender. Then second key we have is age, its value is let's say 21. And then we have a city. So city also, let's say it is a nested one. So let's say we have address as the key, and then in the value of key, let's say we have another dictionary, and this dictionary has a key name, let's say city. It can be let's say Delhi. I forgot the colon here. And then it has let's say another pair, that is zip or zip code. So this one is also having some value or whatever it is. So this, it will create a dictionary for us. Now, because it is a dictionary, we may want to convert it. So let's say if I want to store it in a file, right? So this is a object, and as a object, we can't store it in a file or like play around file. That is where we need to convert this dictionary into a string that can be stored, and that string formatting is called as JSON. So how it calls is that, let's say if I say my string equal to, we have this JSON as a module available. So first we need to obviously import it. So we can import that module, and then we can use it. So the function we need to call it as is dumps. So JSON dot dumps. It is like we are dumping it, whatever we are dumping, it will convert that to a JSON string. So now if I let's say try to print this my string, so it will be printing it as a string. Now this is a string, not a dictionary anymore. So if we want to confirm it, we can use the type here of my string, and now it is a string, and string can be written to a file directly. So although here it looks like very similar to this original dictionary that we have created here, but this is a dictionary and this is a string with these symbols and everything. So this is, I would say, a string in JSON format. That is how we understand these. And if we want to convert a string back to a dictionary, now let's say if we are reading something from the file, let's say this is the content of the file. By default, it will, if we will read this line, it will consider it as a string, like we have my string. And on my string, we can't do, let's say, my string dot name. That will not be allowed. We will need to convert it back to dictionary, or like convert it to dictionary. So similar to JSON dot dumps, we have opposite of that, which is JSON dot loads. So if I say my dictionary equals to, we have this function JSON dot loads. So it will take a string. So we had this my string that was there, and it will convert it to dictionary. So now if I say we print my dictionary here, and then let's say if I print a type of this my dictionary, and also I want to confirm by accessing its element as well. Let's say my dictionary dot get, we want to get the name out of it. So now if we run it, it has converted it to a dictionary and then printing looks exactly same, so we can't tell it, but we can see that its type is dictionary now, and we are able to access its element also. So this is how we can convert a string in JSON format to a dictionary. And that is why, because it is similar to dictionary and converting between a JSON and a dictionary is very easy. This is very handy when we work on real projects. And apart from just converting, it also has methods like directly writing a dictionary to a file. Because with if we directly try to put a dictionary, it may throw an error or we don't know what will be written. So that is where we use this kind of a function. So let's say if I open a file, with the name, let's say person dot. For JSONs, normally we use dot .json, although we can use dot .txt as well, but dot .json is preferred if we are storing something JSON. So we will say with open, we open the file. We want to write something, so we will specify w as file. And then to write any JSON or to write any dictionary object as a JSON in the file, we use this function like JSON dot dump. So previously we used dumps that will convert it to a string. This time we are using dump that will dump it into the file directly. It will not convert or provide it into a variable or something. So here first we need to provide the dictionary that we are dumping, and then the object of the file where it will dump it. So if I run this one, now we will find the file. This one person.json has been created, and here it has written the data as JSON. So now this is a text that is in the JSON format that is available. So this is how we can use it. And similarly, there is like opposite of this as well that is available. So if we want to read our dictionary back from any file, so this time we will say we are opening it in the read mode, and then the opposite of dump, it is loads. Sorry, it is not loads, it is load. Loads is to convert the string. This is like load. Similar to dump and dumps, we have loads and load. So here we don't need to specify the dictionary because we are reading the file this time. And then we can say like my new dictionary, and this is how we will get it as dictionary. So if I try to print now, let's say my new dictionary dot get, and then get the name out of it, I will be able to get it. So it has read this file, it has converted it, the JSON string it read, it automatically converted to a dictionary, and then from the dictionary we are getting the name. So that is how like this JSON, these four functions can come really handy when we work on real projects. So now let's combine all these learnings and do a exercise so that we get it completely. So here what we will do is uh, we need to like use this, if some file is existing or not, we will use if this file is existing or not, then build a dictionary around it. So we will start with a file name variable. Say let's say its name is notes.txt, and then now we will create a dictionary with the name report. Here we will put three things. One is let's say file name colon the name of the file name variable. Second thing we will do is we will check whether this file is there or not. So let's say we can say is, or let's say does file exist. So this is a new thing. So how we can check if file is existing or not? So we have this OS module, then dot path dot exists is a function. So here if we give our file name, it will be able to check whether the file is existing or not, and then return true or false. This can also come really handy when we work in projects. And just to add another item, we can say like checked on when did we check it, and here we want to provide our current time. So that for that one we will read the time, let's say using our datetime dot now, and then convert it into a string. And here I forgot the comma, that is why it is showing that way. So now our dictionary is ready. To confirm it, let's try to print it first. So we can see it is checking this file name. True means file is there. It is checked on this time. So our dictionary, it is ready now. Then we are saying like save it to report.json with json.dump. So what we will do is like with open, we will open our file. File name will be like report.json. We want to open it in the right mode as file, and then we will use the json.dump function. So here we need to provide our dictionary that we are dumping. and also the object of our file. So if we run it now, it will create that report.json, and whatever dictionary is there, it has dumped it there. Now the next task is we want to then use try block thing and read this file and print it. And we also want to handle file not found error. So if we use some name that doesn't exist, then this open method, it throws an error which is file not found exception. So let's see how we can handle that. So we will start with a try block. We will say with open, and then we can say it will be report.json. We want to open it in the read mode, and then we will say as file, and then we can say like my report equals to, we want to read it using json.load, and we want to load this particular file. And then let's say we want to print what was inside the file. So we will say my report. And then if this file is not there, then we want to handle the exception. So we will say except, then file not found error is there as E, we will say, and then we will print the message that error happened. And then equals to, we will say the message that is coming as part of E. So if I run it now, it has written that file, it has read the file again, and then it has printed the content of that. So we can see the content here. So it is able to read that file back, whatever it has written. And here if we use some wrong name for the file that is not existing, and then if we try to run it, so writing part is successful, but while reading it, it is saying error happened, no such file or directory. So this is another type of error that we need to handle while working with files. So this is all I wanted to explain in this chapter. So here we understood how we can use the OS module for getting current directory, listing directory, or checking if a file is existing. Exit also we understood. We understood how to play around date and time, and then we understood how to read and write data into files. And we also understood like how we can play around the data in JSON format and handle any missing file using try except block. So that is what I wanted to cover here. I hope you are excited for the next chapter. So let's go to the next one. So now the next module, it is about working with APIs and external data. So as we know already how to play around files, so now we will understand how can we connect and work with external systems that are remotely available. So to work with such systems, like we use API calls or we use SDKs. So that is what we will understand it here. First, let's understand like what is an API and how we can make it work. So let's say there is this website AZ5, and this website, it can provide some data to us. And how it can provide it, now I have opened my Chrome. I'm not using any Python. So if I simply open it, by default it will say like missing name parameter. So how I can provide a parameter here is question mark name equals to whatever name we can provide. So now it has returned some response, count, name, and age. So what this website is all about is like they have some algorithm they have run of like they have gathered the data of different people across the world, and then like they, based on the name, they saw what is their age. So based on like my name Narender, they are saying like the people with the name Narender, their average age is 43 and count is 254. So they check the data, they have the data for let's say 254 people. So I hope I live longer, but they are saying it is 43. Let's see. But if you notice here, so we called a, so this is how here we actually called an API, application programmable interface. And the response, if you see, so it looks like a JSON. And that is why working with JSON is more important. So whenever we work with external systems, we play around these JSONs. And we get this option pretty print. So just to like show it in a pretty way, but this is optional. But what I want to show here is that we are making an API call, and then this is the response in JSON that we are getting. Now let's see how we can do the same thing in Python. So now we are back in our notebook. So to make any API call, we have this module that is available, which is like requests. So this module, it is not available by default. So if you remember when we were talking about requirements, that is when we had specified it and then installed it. That is how it was available. But we can install it manually also, or whenever we want to. And now how do we make this call is like we have this requests, then we have a function here dot get, and here we need to specify the API call that we want to make. So let's say here question mark name equals to Narender. That same API call we are making here. It will make this API call, and the data that we are getting, we will store it in a variable with the name response. So now let me run it. So here the execution is complete. The data is there in this response. So first of all, like how do we know whether it has returned some successful data or not? So this response, it is an object, not as a string or something directly, because we can get so much information back from any API. So first what we will do is like this response here, it has a status code as a parameter. So we will try to read that. So here you can see we are getting this 200. So this here actually there are different standardized status codes which are followed across the world. So 200, it means it is a successful response. Anything other than 200, like we have different categories of errors. So whatever is other than 200, that means it is an error. So that is why this status code is very, very important. And this is the status code. Now let's say if we want to see the data, then how do we get it? From this response that we got, we have this function like dot JSON. This will give us the data. And then let's try to print this data. A note date, I want to print the data. Let me rename it. So if I run it, now we can see whatever JSON we were getting in the Chrome, we were able to get it here. So this is the JSON data that came up with the response here. And although we are printing it, and here the thing is that it looks like a string, but this is not a string. It is a dictionary that is there. So if we want to print, let's say data dot age, we will be able to get it. And if we also want to check its type, we can always use the type function. So, so here it is not providing age. Oh, we need to use that get function. Directly we can't get from dictionary. So dot get age. And now if I run it, so we are able to get the age, and we can see its type is dictionary. So when we use this function from the response, we can get the dictionary, or then we can use whatever data we want. So this is about the same, how we can get age or how we can get some specific element out of the response. And then in this case, like we specified the parameter as part of the URL as well. And in like other APIs that are available, or like in real world APIs, we may want to send more and more parameters along with this request. So there is a standardized way to pass these parameters as well. So how do we do it? Let's say this one, instead of passing it here as part of the URL itself, here we get this another option like params, and then here we can provide it as a dictionary, like what is the key and what is the value that we want to provide. So this will also pass the same name parameter and do the same thing. So here we will simply print the JSON that we are getting back. So we got the same thing. So this is how standard parameters we can pass as like not as part of URL, but as a separate parameter, because in real world we can have so many parameters. And then the next one is like how do we handle uh, failures for the responses. So we saw that status code 200, it means it is a successful request. But if it is like anything other than 200, that means it is a failure. So that is why that is how we handle it. So we use it like this kind of a condition. Let's say if response dot status code is equal to 200, then we do something saying like it is success, or we can even, let's say, print the message that is coming up. Let's say response.json, and in the else part, if the status code is anything other than 200, then it means it is a failure. So we will say we will print here, and we can say this is a failure. And we can even use raise if required. Let's say raise exception, and we can say like API call has failed. So now if I run this, so if everything goes well, we are going here because status code is 200. But let's say here if we are using some URL that doesn't exist, then let's see what will happen. Then we are getting an error message as expected, because status code is not 200 anymore. So this is a failure, and it is printing our own custom exception message as well. So this is how we can handle failures while working with APIs. So now, as we understand uh, how to work with generic APIs and handle API calls, failures, all these things. Next, let's understand what is an SDK and how we can interact with it using API calls and all. So first, let's understand what is an API key. So here we used an API that is free to use. Anybody can make this call. Some limit is there, but we can call it how many times we want. But there are some APIs which are like not free. We need to generate a kind of password and key so that we can interact with them, and they can also know that who is using our system. They can apply some payment system and all. So that is for that purpose we have something called as API key. And now we will generate an API key to talk with Gemini, the LLM, programmatically. So first let's understand why we need it and then generate an API key. So if I go back to Chrome and if I open gemini.google.com, so this is a chat interface where we can talk with this large language model. So here let's say we can say how are you, or we can ask any question as well. Let's say how to use dictionary in Python. So then it will check it internal knowledge and then provide a response here about how we can play around with dictionary in Python. And currently what it is doing is it is connecting with a model here, a LLM model here that is available. And then it is talking to the model and providing this response. Now, this same thing, if I want to do in Python, then we will need a API to connect with that model and talk to it. So for that purpose, we will first generate an API key. So we will say get a Gemini API key, simple as that. And then I will open this using Gemini API keys and create or view a Gemini API key. I will click this. And here it is showing me the API keys that I am using. But if you are using it for the first time, it will be blank. From here, we can create an API key. So here we need to give it any name. Let's say Python test, and then it will generate it. So here the key has been generated. This is the API key. I will copy it from here. Once we close it, I don't know if they will allow to copy again. So it is better to like copy it to a notepad or something. So I have copied it from here and then I will close it. So we have just generated our first API key. And these APIs, these are free to use. So you don't need to set up any billing or add any payment information. So now we will go back and use this API key. So we are back here, and API key, like I am telling, it is like a password. And if you still remember, we still password or important sensitive information in our .env file. So there we will create a variable Gemini API key, and there we will paste our key. So here I will remove this. So we will say Gemini API key equals to the key. So you shall generate your own. By the time this video will be uploaded, I would have deleted this one. So don't spend effort copying it and all. Then what we need to do is, now we need to load that key. So here we will use that module like import .env. And then this module, it has the function like load.env. So now the data will be loaded, and after that we will try to read the API key. So we will say API key equal to os dot os. Also we need to import first, then we can use it. So let's say import os, and then we will say get env, and then the name of the variable that we had specified. So in our case, it was Gemini API key. So we can try to print this API key, but that is not a best practice because printing a sensitive information here is not good. So how do we do that is just to confirm that it is there. So we use simply if API key. Then we can say like print API key is found, and else we will say it is not found. So we will say API key is not found. So if it is available, it will say found, because if its value is there, it will go there. If it is not there, then it will be none. None, it will go here. So let's go ahead and run it. In our case, it is saying found. That means it has found it from the .env file, and it is available in this variable now. So now let's go ahead and make the call to Gemini. And to make that call, like we will use something called as SDK. SDK means it is software development kit. So without an SDK, like if we use a normal request API call, that is also provided by Gemini, but that is a complex process. So for such things, what they do is they prepare a wrapper around the request so that they can customize it accordingly and user can use it in a very friendly way. So that is what we will be using here. We will be using the Google Gen AI SDK, and that is also nothing but a library that we need to install first. So first we need to install this Google Gen AI library that I think currently we have not yet installed. So we can install here, or we can go to terminal. We can install there as well. So in the terminal, we need to simply type pip install Google Gen AI. So now it is downloading that Gen AI related libraries, functions, files, whatever is there. And once it is installed, I can close this terminal and go back here. So first of all, we will import this module. So we will say from Google import Gen AI. And now to interact with Gemini, we need to first create a client of that. So how we will do is we will say client equals to Gen AI dot client, and here we need to pass a parameter that is API key. So API key, it is already available in a variable here, API key. So that is what we will pass here. So with this, what it will do is it will make a connection to Gemini. Internally, it will be using that requests kind of thing, but we don't need to like worry about all that URL and everything now. That is how like it makes it simplified to use those calls through this SDK. So now as we have created a client, now we will interact with its models and then generate some content. So what we will do is we will say client dot models dot generate content. This is a function that is available that we are calling here, and this function also takes some parameters. So first parameter, it is model. What model we want to use? Gemini, it has so many different models. So here we will be using this Gemini dash 2.5 dash flash. It is a quick model. So the name I have provided here for your reference, and then we need to provide here, let's say, contents. So here we will be providing the content or question that we are asking. Let's say how to use APIs in Python. We can ask anything, whatever we want. Tell me a joke or whatever. So this is how like it will make a call and generate some content for us. And that content we will receive in a variable called result. We can give it any name, but let's say we are getting it in a result. And after we get this result will be also kind of a dictionary and a object of a class. From there, if we want the real response out, then that will be available in the result dot text, like the text that is coming in the response, that is what we are reading here. So with this, our SDK call is ready now. So let's go ahead and make this call. And this one, it threw an error. So if we look at the error message, it is saying like this model is no longer available for new users. So basically they keep changing these models and all. So we will ask Gemini only like what is the latest model so that we will use it. So if I will go here, then if I search for this message, probably it will provide the list of the new model that we can use. So now it is saying like instead of 2.5, we can use 3.5. So that is how like it is now. So when I prepared the exercise, this was the model. Now they have changed it to 3.5. So that is the latest model which is there. And now we can see that our SDK call, it is working now. So how to use APIs? It has provided a very detailed response. So this is how we can interact with these LLM models using these SDKs. And now just to put our learnings all together, we will want to use, let's say, the requests and this SDK model together to do a small exercise. So we are saying like fetch the predicted age for the name Noah from this Azify API, and then make a call Gemini to write a very short and friendly sentence about someone with this name and the predicted age. So let's try to do that. So first, like we will copy this time the code from above so that we don't have to do it again. So I will copy this part, and then this is where we are trying to get the age here. So I will remove this name. We want to use, let's say, Noah. We can go with any name anyway. And then this time it will be working fine. It will provide us the age there. So let's say if I want only the age part, I will say that response dot json dot age, and then we want to print this age. So yeah, it is a dictionary, so it will not be accessible this way. We need to use dot get like we were talking about previously. And now age is there in a variable 38. So now let's take this age and make a call to our SDK that is there. So I'm copying this code, the SDK code again here. And then this time, instead of saying like this thing, we will say something nice to a person with name equals to Here we will say F so that we can provide it dynamically. So yeah, name we can directly provide, let's say Nova, and age equals to the age variable that was there. And then let's see what nice it has to say. So we can say in two sentences so that it keeps it small. And now let's go ahead and run it. So it has first predicted the age. Now it is making the Gemini API call. And now this is what it has to say, like, and at 38 you possess something, a wonderful blend of wisdom, kindness, all that. So this is something it has come up, but we have the response. So here we made an API call, we got the response, we send the response to Gemini, it generated some content, and we have the content. So that is what we wanted to cover in this chapter. And just to recap, we understood the requests, making a get call using status code, how we can get the data using .json, passing parameters, storing API keys and something similar in environment file, and then using a SDK to make a call to Google Gemini LLM and then get some response. So all these we have understood here. And I hope like now you feel like how easy it is to using Python by interacting with the even the LLMs and AI. And that is what make Python very powerful, because anybody new can very easily do lot of things here. And now you might think that we have done so many things, so what more is left is there. So now we will go to the last chapter where we will build some UI as well very quickly. There also we will see the power of Python, how quickly we can build UI as and when required. So let's go ahead and do that. And now coming to our last and final chapter, we will be building UI using Streamlit. So Streamlit, it is also another library or another package that we can use to very easily create UI in Python for any project, any POC, whatever we want to do. So to start using this, first, as always, we need to install it. So I will go to terminal here, new terminal, and here simply I will run like pip install Streamlit. That's all. And now once it is installed, we can confirm as well using, let's say, Streamlit dash dash version. So this is something like specific to Streamlit that we can get it a version, because Streamlit itself is a command. For other libraries, we can't do it. So there is special to it because we get a special UI. So we have to use it in a different special way. So now Streamlit is installed. So what we will do here is that, and this time if you notice, we don't have code cells here. And the reason for that also is that Streamlit code directly we can't run from this Jupyter notebook, because we need to run it from this command line, and by putting it in a table, sorry, putting it in a file. That is how this Streamlit works. But it is not that complex. It is pretty simple and easy. Let's check it out. So step 1 is already there. Now what we need to do is we need to, let's say, create a folder named my app. There we want to create a file named app.py. So what we will do is I will minimize this. We can create this folder, let's say my app, and then inside this I will create a file with the name, let's say, app.py. We can use any name that we want. So this is a blank file it has created for us. So here, first we will start by importing this module. So import Streamlit is st. So import Streamlit is st. St is a short form that commonly used. We can use the full name also if we want. We have imported it. Then the next thing is we need to give some title to our app that we are building. So for that one, we get this function st.title, and we can give any title that we want. So I will go here, and in the next line, I will type like st.title, and I will title, let's say, this is my first app. This is the title I have given. And now I will press Control S to save it. So this dot here, it means it is not yet saved. I will press Control S because saving is very important here. I have saved it, and then we can run our app. So you might think like we didn't do anything. How come it can create an UI? So that is the power of Streamlit. With just this single line, it will create a UI front page for us. With it will be blank for now, but just with one line we can create the UI. That is how powerful it is. And how we can execute that file is that if we are using Streamlit, then the thing is that it is not a normal Python code, like it is Streamlit specific code. So this one we need to execute through this terminal. So here what we need to do is we need to run the command streamlit run, then the name of the file or the path of the file. So first what I will do is I will do cd, and then I will go inside my app folder. So cd my app. Now if you see I'm inside my app folder. We can do this, or we can specify complete path like this while running it, but it is better if we are inside the folder itself. And I will press CLS just to clear this screen. And then now we will run the magic command, which is streamlit run, then the name of the file. So it is app. So if I try ap and then press tab, so it will detect the file also automatically. We don't have to type it entirely. Now I will press enter. So it is asking me to allow this access. I will allow it. And that's it. With this single command, now our UI is running. So let's go and check it out. So if I press Control and click it, or I can copy it and then open in Chrome. So if I control click, it will open it here itself. It doesn't look that good. So what I will do is I will copy this. I will go to Chrome, and okay, Chrome also, it looks like it has opened automatically for us, launched it, or I can provide it and then open myself. So with here looks like while I moving away, I kind of stopped it. So yes, it is stopped now. Let me run it again. So yes, this time it has even launched the Chrome also automatically. So this is my first app. This is a blank UI that it has created with that just single line of code. So if I go back here, I will put Control C here to stop that, and then we will move on further. So now in this blank uh, app, let's start providing some of the things. So here, if we want to write some line or write some text of our own, apart from title is like the title of the app. Every time we can't put multiple titles. So if we want to write some text, the function is simple. We use st.write and then what we want to type. So st.write, and then let's say this is my own text, and save it. Then go to the terminal and I will run it. So this way we can see now the text is coming up in our app. If I go back, I will put Control C and then continue. Now as we are able to put some text, now let's say if we want user to put something as a input. So for that we have another simple function like st.text input, and then we can receive it in a variable, and that we can use in the write function back, so that whatever we type it will write it there. So what we will do is this same thing. So we will say like name equal to st dot text input, and then we put a message, let's say what is your name, and then in st.write what we say is, let's say welcome, and then comma the name that we got from the top one. So I will save it. I will go to the terminal. I will run it. If I press the above icon, it will give me the command that was previously run. That is why it is coming up automatically for me. So I will simply press enter. It has opened my app. This time we have an input field, and some text. So let's say, what is your name? Let's say Narender. Now I will press enter, and the output text or the text box that was there, it is reflecting what input that we had provided. So now let's move on to the next step. I have stopped it. Let's go back here, and then so far, whatever text and everything we saw, it was very simple. So let's say if we want to build a kind of a chat bot, then what happens is we have this special function like chat input, and then that we can use in the right. So instead of, let's say, simply saying text input, we will say chat input. And we will be able to use it the same way. So let's see how this one looks. So let's run it again. And as you can see, instead of showing that text above as a text box, now it looks like a chatbot. Here in the below, we can type anything. So let's say I'm giving Narender here, pressing enter. It is able to take our name and then provide it here back. So this is a chat box now. So now let's go to the next step. So I will cancel it, go back here, and then if we want to the output that we were showing, it was showing it as a like plain text. All right, but if we want something better, that we want to show like a proper chatbot kind of thing, then what we do is whatever question that we took from the chat input, for output also we have this chat message, and then we can write inside that chat message so that it looks better. And for chat message, we have two options as well, like user or assistant. User we use if I, as a user, human, I am giving something. And assistant, it means if AI is returning some response and then it is showing something. And why I am mentioning AI? Because this Streamlit, it is specifically designed to talk with AI. And if you got some idea already, so we used Gemini in the previous chapter to make some call. That is what we will show here as a assistant response when we will go to the further steps. So let's do this step, and then let's see like how it is doing. So we will take a question as input, and then that is something we will show like as a user here. So what we will do is, let's say instead of name, we are saying we are taking it as a question this time. And then instead of simple write, first we will confirm that question has been provided by the user and not empty. So we will say if question has some real value, then we will say with st dot a chat message, and chat message it is of type user. And then what we want is here we will do the same thing like st dot write this same line. And here we want to provide the same question as it is without any change, so that we can say user asked this question. So I will save it. Let's see how does it look like now. So I'm running it again. And this time, let's say if I say, how are you? So now you see in a better way, we have this user icon and the question here. So this is how it looks, a simple like user and a user kind of chat box here, the response here. So now let's move on to the next step there. So now, as I was talking about, we will integrate Gemini here. So for Gemini, as you already know, first thing we need is a API key and the client that we will create a client using the API key. And then we load the environment file, all that. So this piece of code we have already seen previously. So what I will do is I will simply copy this time and paste it into this original file. So that's it. And it is the same thing as the previous one UI wise. So we will not run it yet. We will move on. So now what we will do is the question that was asked, then we showed here in the st.write, then we will make a call to Gemini. So what we will do is we will use this same thing like client.models.generate content. Use this model. Now we know we have 3.5, not 2.5. We will send our question. we will get the result back, and the result that we were getting, that is what we will show in the another like chat message as a assistant, not a user this time. So this is what will be interesting this time. So let's go ahead and build this thing. So until here, let's say we have set up our question. Now what we will do is we will make that API call. So result equals to the client that we have created dot models dot generate content, and then here we need to pass our model name. So this time we will use 3.5, so Gemini dash 3.5 dash it is flash, and then in the contents we will pass the question that was asked by the user so that it will return the answer, and the answer that it will return, we will use the same box here, kind of box, but this time instead of user it is assistant, and in the assistant we will write the result dot text that we are getting, result dot text. So this is how it will work. Here user will ask a question, we will show the question in UI, we will send the question to Gemini, we will get the response, from the response we will get the text and again show in the UI. So that is how it will work. Let's check it out. So let me run my app again. So now this is a real chatbot. So let's ask some question. Let's say uh, tell me a joke. Let's say what kind of joke it can tell us. So here we can see for user, it is showing that this is the message has been sent by user. Now it was sent to Gemini, and this is the joke that we get back. Like, why did Scarecrow win an award? Because he was outstanding in his field. So this is a, I find it silly. You may find it funny, whatever it is. But what we got our joke back. So this is how we were able to communicate with a LLM, and we were able to get our response back. Now if I ask another question here, let's say tell me another joke. So now it has been changed here. It is sending again to Gemini, and it will give us another joke now. So now this is another joke. Like, my wife told me to stop impersonating a flamingo. I had to put my foot down. Uh, I don't know if I really get it what it means, but this is another joke from Gemini. So if you notice, like whatever we are chatting, so it is showing the question and answer, but older one it is replacing. It is not remembering, and it is not showing it is a proper chat. So now let's do that as a next step and our probably final step. So let me cancel this. We will go back here, and then remembering the past message with a state. So here, like this is the code. So this time, like this is, I would say, uh, a longer code. So I will copy this time instead of typing it manually. So I will replace this entire thing that was there, and we need 3.5 that I remember. I will change it in the original notebooks for your reference. Let me save it. So this time, let's see what additional thing that is there to remember uh, the question and answer. So if you see the question that was asked, here is the additional line, like st.session_state.message.append. So here, this Streamlit, it has something called a session, and in the session we can keep appending more and more message whatever we want. In every message we need to give a role and a content. Why we want to give a role? So that it show that proper icon whether it is from user or from the assistant. So this is how, like, we are setting, providing the appending the question here, and whatever answer we got, that also we are appending in the session in the same way. And then this is another additional thing. So whatever history is there, that entire history we also want to show in the UI. So for that, we read the messages from that session state, and then from the message we get the role. So we use the chat message and specify the role, like we were specifying manually previously, and content we show in the st.write. So that is how the historical session, whatever it will be able to maintain that now. So I have saved it. Now let's go ahead and confirm it is working really well. So now it is here. First, let's ask something. Let's say, how are you? Because it is not good at telling jokes, we can say. So yes, we got the response. Then we can say like, this is probably our final question. We can say like, is Python easy to learn or difficult? So let's see how LLM think whether Python is easy or difficult. We will get our final answer. So here is our answer. It has given a very long answer, we can see. So it is saying like it is considered one of the easiest programming language that is there to learn. And it is giving some like reasoning behind it, why it thinks it is easy. And if you notice this scrolling and everything, it also came automatically. And that is how powerful this library is. So just by using couple of lines in the code, we were able to do it. We just need to focus on functionality, what we want to build, the UI, and the the core handling of the interaction between all these elements. These are coming out of the box from this library. So now I'm back. I will cancel this and I will close this terminal. So that is all I wanted to talk about this Streamlit. So just as a recap, we installed it. We understood how we can run any app built using this. We understood how we can add simple titles, simple text, how we can write and take as input, and specific to like assistant or LLM related chatbot. So there, how we can use like a role specific chat message and then share the content back. And we also understood like how we can maintain state when we are going through multiple messages in a round. So all these things we have understood now. So these are all the topics I wanted to cover in this video. I hope you really enjoyed this course, and if you want to support my work, please put a like and comment on this video. That's all for now. Take care. Bye bye. Happy learning.